Good evening. Right. Let us have yesterday's homework question. Right. 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 See, concentrate here. This is the question I gave you as the homework. Right. In this, what is the given data? First point you have to concentrate. The line-to-line input voltage to the three-phase 50 hits AC circuit shown in figure is 100 volt. Line-to-line voltage VL is equal to 100 volt. Assuming the phase sequence is RYB, phase sequences RYB he has given. The wattmeter readings would be, but be clear, he has mentioned the sequence as RYB, but if you see the figure, he has taken negative sequence or positive, reverse sequence or forward sequence means reverse sequence. Why? Anti-clock or clockwise he has taken. That you have to understand. Sir, RYB sequence means RYB means R first, Y later, B later means in the given circuit. What is the sequence order he has taken? RYB only, but which direction? Clockwise direction. But so far, all the theories, all the concepts you have taken for which one year? Anti-clockwise sequence we have taken, but here it is taken as clockwise, means whatever we have taken so far and whatever he has given the numerical question, exactly opposite fashion. Clear, guys? Right. After that, same type you have taken now R and then corresponding other phase to combination here. Okay. Now, sir, what is Z phase he has given? 5 at an angle 60. Z phase is 5 at an angle 60. Very simple method. If you have gone through the entire procedure of mine, right? In the day before studies class, what are the procedure I have taken? You would have gone through that. You can understand this, right? I have taken, sir has taken in the classroom like this. What is that? This is R, this is Y, and this is B. Okay, what is the sequence? RYB sequence. But what is it? R, Y, and then B. Which sequence? Anti-clockwise you have taken. But in this question, he has taken directly which one? Clockwise sequence. He has taken clockwise. But RYB only, but clockwise you have taken. But don't think like, sir, clockwise means R, B, Y, not like that. He has changed the corresponding total scenario. What is it? Same RYB sequence only, but clockwise means whatever we have taken in the explanation point of view, that will be exactly opposite. No, that will be exactly opposite. No. So therefore, what a formula now directly, phi at an angle 60 means, is it implying which load? Lagging load or leading load? Lagging load only. Why? Phi at an angle 60 means it is representing R plus JXL model. R plus JXL model. Therefore, phi at an angle 60. Okay. After that, lagging load, right? Now, sir, in our lagging load explanation, what was the formula we have got? In the lagging load explanation, what was the formula we have got? VL IL cos 30 minus 5 we have got. But where? In the lagging load, in the RYB sequence, anti-clockwise sequence, we have got it. So therefore, 30 minus 5. Okay. Now, sir, W2 what we have got? VL IL cos 30 plus 5 we have got. Okay. But be clear, guys, be clear. This is the sequence we followed when we followed RYB, that too anti-clockwise sequence. So with this simple shortcut is anti-clockwise sequence, we have got this. So clockwise sequence, what will be there? Clockwise sequence, what will be there? So exactly opposite notation. Minus 5 becomes plus 5, plus 5 becomes minus 5. If you would have understood my topic clearly, that logic you can apply. RYB sequence, anti-clockwise, has been explained in the classroom. RYB sequence, but clockwise sequence has taken. So therefore, anti-clock to clockwise, 180 degree shift, automatically plus become minus, minus become plus. So therefore, what is that? Whatever may be the value, VL IL cos 30 plus 60, automatically 90. So therefore, first wattmeter is 0 watt. First wattmeter reading is 0 watt. Many people give that. Many people give that. Yes, very good, very good. Yeah, Vasisha, that is only very good, very good. Sir, here one student sent me two solutions. Sir, which is correct? You told me. Very good question. The point here is VL IL cos 30 minus 5. Sir, what is VL? VL is given as 100. Okay. Cos, I'll write I later. Cos 30 minus 60. Cos 30 minus 60. Be clear, guys. With this entire idea, concentrate. Sir, IL is equal to I phase. Why? It is a star connection. Star connection. IL is equal to I phase automatically. IL equal to I phase. Okay, right, sir. What people are doing mistake? Few people, but many people give the correct answer. They are doing like, sir, IL is equal to VL by Z. VL is 100 by 5. Is it correct or wrong? Only magnitude I'm taking. Anyway, angle you have taken, no. Is it correct or wrong? Means absolutely wrong. Absolutely wrong. Absolutely wrong. Sir, why? Sir, why means concentrate here. Sir, IL, which one here? Line current. VL, line voltage. But Z is per phase. One phase, one phase, second phase, third phase. So therefore, per phase, always be clear here. Everyone, IN are electrical people. Can you concentrate? The load will be are the resistance and reactance and resistance and reactance and impedances are always expressed per phase only. Expressed per phase only. Per line, impedance cannot be given. How I mean simple logic. Our house one load is there means is it per phase system or any 2-3 houses combined load, combined fan, combined AC will be there? No. Therefore, one house load means one per phase only. That is called as load. That's why impedance or resistance or reactance all will be expressed per phase only. Whether it is mentioned or not mentioned, take it for granted per phase only. If any doubt is there, in my house, the refrigerator is there, that is my load, or 2-3 houses combined load means my load only. My load means my house means my phase. So single phase only. That's why IL equal to VL by Z, we should not take. IL equal to what you have to take here? V phase. IL is equal to, what is it here? VL by Z we should not take. So what you have to take now? I phase you have to take. I phase is equal to V phase by Z. Sir, what is V phase? VL by root 3 by Z. That's not the actual point. Anyway, finally I phase equal to IL only. What is that? VL by root 3 by Z. What is VL? 100 by root 3 by Z is 5. Again, people are getting 50 here, getting confused. Why? Already you're taking the angle over here. So automatically you can take the magnitude only. That is sufficient. What is the answer? Right. Bhavani, sir, it is balanced. Can't we take three multiple impedance? No, three multiple impedance will get which one? Yeah, total impedance. But what you require? Line notation. In one line, how much is there? He is not adding these three. You're saying that here 5, 5, 5 are there. All must be added. Directly can be added here. It is AC system. AC means vector combination you have to take. Don't add arithmetically. So that's why always per phase impedance is the no, per phase current you get it. That's it. Why to calculate total impedance here? Bhavani, why to calculate total impedance? Not required. Not required. Yeah, I think Imtiaz Pasha, I think. Now got the answer right? You send the answer with 100 by root 3 by 5 or 100 by 5 only, which is correct you told. Yes, I wanted to clarify in the classroom. What is the answer? 1000 watts. Right. Tricky is mathematics. Yes, that's only. Any changes reversal in cos angle does not change. Right. Yes, that only. No problem. Right. This is the direct method, shortcut method, we can say, by the corresponding conceptual theory, this one. But people are still asking that, sir, do we solve by the normal method? We can do normal method also. By see, for the purpose of practice, for the practice purpose, I am solving this, but not required. It is sufficient. But many people are asking me like every question by the phasor diagram, why can't we? Every question can be solved, but whatever the question I gave you, this type of question I gave you, this type of question I gave you, that's why be clear. Here I gave you one question like this. In this question, phasor diagram is not required because already he has given balance. As we are taking VRY, VYB, and VBR, already we have taken some 400 at an angle 0, 400 angle minus 120, 400 angle minus 240 means indirectly we are depending on phasor diagram only. Separately phasor diagram drawing it, don't take one thing. Second thing, here resistance is shown. Resistance is shown means the load should be taken as resistive load only. Sir, he has not mentioned low. In the figure it is given that only resistive, only resistive. That's why you have to take resistive. Even though you draw the phasor diagram, you will get the correct answer only. But sir, as the load is not mentioned, why can't I take inductive load? He has clearly mentioned that 100 ohm, R equal to 100 ohm, R equal to 100 ohm, something he mentioned. So therefore, resistive load you have to take. That's why for everything, don't try to draw phasor diagram, right? Yeah. Karthik, yes, that only I'm saying now. Yes, very good, very good. Hemak, very good. Yes, I'm going to do that only because anyway, people will be asking, like, maybe asking that, sir, why not by major procedure? Yes, I'm doing that. Procedure is always procedure. There is no problem. But as we know the entire theory, simply, what is it? Yeah, I reversed these two in a two-step answer will be there. Okay, right. Why I told you this, why I told you this means the people are getting confused. Simply, they are not concentrating on the terminology here, RYB, etc. They are taking here minus, here plus, here minus, here plus. They are taking blindly, right? In the options, how the options, here options 0, 1000, 1000, 0. Both options will be there. What is asking? W1, W2 order wise, which is to be corrected first or second? Both are same? No, both are not same. First only correct. If you take the wrong solution, second will be coming, but second is wrong. That's why I told you the importance of sign. How can we reverse this? Normally, I told you. Right. In the deflecting torque, which component will get, sir? I'm getting cos. Yeah, many people are saying that cos only. Yeah, sine or cos. Just I gave you some idea purpose. You don't worry about it. Cos alpha, 2 cos alpha something or 2 sine alpha something will be there. No need to worry. Anyway, alpha is constant here. Cos alpha, sine, no problem. A few people message that cos alpha is there, but a few people message sine alpha is there. Kindly go through that simple mathematics only. Don't worry. Right. Now, normal procedure I'm taking here. What is that normal procedure? W1 and W2. So what is W1? Concentrate here. Again, I'm repeating this is the last model in this power-based questions. Concentrate here, sir. V R to Y. We should take RY or YR. RY only because in the R phase we have connected the wattmeter. Therefore, VR first we have to take. VR we have to take first. Right? Concentrate. Here VRY. So therefore I'm writing here VRY. Sir, current IR2N. Why is not the point is there? So simply IR cos of angle between VRY and IR. Clear? Right. Sir, second one. From where to where? B to Y. VBY. And current is IBN. So IB only. So therefore, what we can write? VBY IB cos of angle between VBY and IB. VB and IB. Sir, what is VRY? What is VRY? VRY is VRN minus VYN. So many times you have taken. VBY, VBY, VBN minus VYN. VBN minus VYN. Okay, now let us draw the phasor diagram. This is VRN, VYN, VBN. Clear? Right. Let me explain first. Concentrate here. R, Y, B. Let me explain this. So what is the load? Lagging load, 60 degrees. Is that no? So therefore, IR you require. IR will be lagging the VRN by 5 degrees. Actually, not 5. It is given, sorry. It is given as 60. Yes, I'm taking this. Here, this is IR. What is the value? 60 degrees. 60 means it will be reverse equal. IB also you require. IB. This is IB. It is also 60. Why? IB lags the VBN. IR lags the VRN. Automatically 60 and 60 will be there. Okay. Sir, VRN is there. Okay. Sir, minus VYN. Simply reverse this. What is this? Minus VYN. Because as the 60 is there, no, same phase will be there. But don't write IB is in same phase. No, that is happening with the load notation. After that, VRY. This is VRY. After that, VBN minus VYN. Simply, what is this? VBY. Okay, now let us write. W1 is equal to VRY line voltage 100. Is that no? And IR already we have got it now. 100 by root 3 by 5. Magnitude is same. Okay. And what is that? Angle between these two. Cos of VRY and IR. This is VRY and this is IR. VRY and IR. What will be there? 90. So therefore, cos 90 is equal to which value? 0 watts. Clear? Right. Next one. Sir, W2 100 into 100 by root 3 by 5 into cos of what is it value? Cos which value? VBY and IB. VBY and IB. How much value it is? 30. This is 30. So cos 30. Same thing you have got. Cos 90, here cos 30, magnitude is anyway same. So you'll be getting the answer as 1000 watts. That's why be clear with the terminal. This is the basic approach, but this is the simple shortcut I gave. That's what I'm waiting. Yeah, that's what I'm waiting. Sir, even if you want, you take the reverse, but be clear, sir. Circuit connection RYB, circuit connection RYB. What is it here? Phase sequence is the circuit connection RYB. Clockwise is there. Yes, I'm giving that, sir. Same question. Practice with the RYB notation, clockwise notation. You will be getting the similar result only. No need to worry. But I have taken RYB because normal phase sequence is like this. I have taken, but for having the idea, of reversing the concept directly shortcut, I have taken this entire thing. Actually speaking, no need to take RYB in the clockwise because normal approach will be RYB approach only. All these values are based on the clockwise only we have taken. If you are taking clockwise and again one more time, it will be like reverse notation. So that's why standard notation is this only. No need to worry. Clear? Otherwise, simply follow the shortcut. No need to worry. Right. In case some, if you are not changing the sign, V phase at 0, I is 1140 with minus 60. Can we write minus 60 in the place of 5? What minus 60? What minus 60? Imtiaz, question is not clear. Kindly elaborate it. So this is the way of calculating the total value, right? Homework question. Many people ask that, sir, answer. I told you, no, in the next day, always I will solve the homework question. Then I will go to the next topic I told you. But still many people message. Almost my inbox is filled with those messages only. Sir, answer. Come on here. I will give you any time. At any time I will give you. No need to worry. Clear? Right? Now. Right. Did sir after reading the notes? Very good, Vasishtha. That's what you need to foresee after the class. Immediately don't start the homework question. No, follow the entire notes first. See, if I give you the homework today, tomorrow before 5 you have to ready. That is the main thing. Tomorrow at 4 o'clock also you can start the homework question, no problem. But after the class, immediately starting the homework question, going to that, don't do that. First follow the class notes. But I'm requesting everyone to follow the shortcut, because so that you can understand how it is changed, how it is not changed, etc. Nice. Right. I told you many a times, kindly Bhaskar, I think, go and watch the recorded videos, how we have to take voltages. I told you already how we have to take voltages. VBY or VYB. Plenty of times I explained. Now also I revised. This is the corresponding thing. How VBA, how VYB. Kindly go back and watch the video. You will get it. No problem. Right? That's what I told you. Here RYB sequence must be taken as it is only. This shortcut I gave you, in terms of understanding of my procedure to this question model. That's what I told you. If you reverse it, you will get the reverse answer. That's why we should not reverse. Why? He told that RYB phase sequence. But by the why I gave this shortcut means, concentrate here. Actually, phase sequence means for only phasors, not for the circuits actually. Kindly try to understand. Phasor diagram means for the phasors only, not for the circuits. But for giving this shortcut directly, I have taken my circuit approach and his circuit approach. That's why I reversed it. But generally, whatever may be the terminals they have given, always phasor diagram. RYB phase sequence means RYB anti-clock only you have to take. Don't. That is the reason why. Let me explain. I told you. That's what. This is the correct approach only. I'm repeating this point. Those who join late, whatever the circuit given, right? RYB or RBY. Generally, if he has given that RYB phase sequence, for example, if you follow the main procedure, always anti-clockwise sequence only RYB only we have to take. That is a proof already gave you. But I wanted to give the shortcut directly. That's why my approach and his approach is reversed. No, I reversed it. That's it. That's why circuit wise reversed it. So I reversed the concept. But phasor diagram means always you have to take RYB. He has not mentioned that which sequence. So RYB positive only you have to take. I equal to V phase by Z phase. That is 0 minus 60. What is that 0 minus 60? Right. Next, in the energy meter, we have taken the construction, operation, all we have taken, right? Right. Okay. Right. Now the concentrate here. Kindly concentrate. Here in the construction, just I'm giving the brush up. What is that? Driving mechanism, rotating mechanism, braking mechanism, registering mechanism you have taken. Okay. In this potential coil, current coil will be there. Potential coil, high resistance already there. And by utilizing the corresponding copper shading coil, we have taken high inductive notation also. Current coil is anyway low resistance, no problem. Rotating mechanism by aluminum disc. Braking mechanism by permanent magnet. Registering mechanism by gearing pinion mechanism. Gearing pinion mechanism. After that, we have taken the corresponding total formula. Power measured, what you got? V into I into sine delta minus phi. Sine delta minus phi. PT, what you have got? V into I into cos phi. Some error is there. Yeah, definitely error will be there. That you have taken. And based on this error formula, percentage error formula also you have taken. Clear? Now, the point here is, whatever the topic we have taken this class, I'm giving the note for that entire thing. Salient points I'm giving as a note now. What is it? Concentrate. First of all, here, the delta value must be near to 90 we have taken. Delta value must be near to 90 we have taken already. Listen, near to 90, what we say? Ideally 90. Ideally equal to 90, but not possible. Okay, right. So this is made by which one? Is made by which one? Yeah, by making the potential coil highly inductive. How? Copper shading band. So therefore, this can be achieved. This can be achieved by using copper shading band. Copper shading band of highly inductive. Okay, now be clear guys, by using the copper shading band, you're increasing the delta, you're decreasing the delta, you're increasing the delta. So therefore, what we know, this process, therefore, this phenomenon or this process is called as, lag adjustment. Why? By using this only, by using this copper shading band, coil or band only, we are having the adjustment of delta to 80, 85, 88. Manufacturer, he will check it. 80, error is more. 85, okay, like that. 85, 88, max generally 88 degrees is the common use. Whatever the procedure we did, that entire procedure is called as lag adjustment procedure. Lag adjustment procedure. In the same way, sometimes we can call this as this copper shading band is also called as lag adjustment band also we can say. Lag adjustment procedure, lag adjustment coil, or lag adjustment band also we can say. Right? Everything I gave you, only this what I wanted to give as a special note so that I can revise the entire topic. This is called as lag adjustment procedure and lag adjustment band. After that, sir, what is a meter constant formula? I gave you already. Number of revolutions gives one rotation of the gear. One rotation means kWh. Therefore, kWh. Number of revolutions per kWh is the unit of meter constant in the energy meter. Okay, one more. Sir, what is the percentage error formula? Already we have taken this Pm minus P, that is okay. In the energy point of view, energy measured minus energy true by energy true into 100. Energy measured minus energy true by energy true into 100. This is what the complete, what is it? Energy related error formula. Nice. Kindly concentrate. This is the main confusion. You're missing something, Vasishta. You're missing something here. This is VL is equal to V phase. This is IP. This is not beta, guys. I told you clearly in yesterday's class. Beta is there in EMMC device. Delta is to be taken, or delta has been taken in energy meter. Delta must be high. It is not beta. Actually, in our topic, energy meter, we did not get beta anywhere. That's why coil is same. Potential coil means there also potential, here also potential, but there potential coil must be having less inductance. Potential coil must be having less inductance. Therefore, what is it here? Beta must be low. Why? Tan phi, tan beta formula. But in our case, potential coil means what? Corresponding delta must be high. Kindly don't compare. I compared already. What is it? There beta, here delta. Beta, EMMC, low inductance. Delta, energy meter, high inductance. Both are equally good. That's why instrument to instrument, I told you, DC machine, induction motor, you compare unnecessarily. Same thing. So that's why don't compare unnecessarily. Right? Because that construction, that operation, that application is different. Here also, everything is different. Is alpha approximately zero, sir? No. Is alpha approximately zero? No. That alpha depends on aluminum structure. That we have not neglected. We have made that as constant. We have made that as constant. Right. So this is a total discussion regarding energy meter construction operation corresponding in the mathematics and formula we have taken. Now let us have some questions. After that, I'm going to take one more topic in the energy meter. We'll conclude the energy meter. Now let us be ready to solve the questions. Direct question. Read this. Come on. Option B and option C. Two people are giving two different answers. B and C. Let us verify. Direct question here. Direct question. What is that? Here, 220 volt. He mentioned V is equal to 220 volt and I is equal to 5 ampere. Power factor is equal to unity as well as 0.5. 1 cos phi is equal to 0.5. And he has clearly mentioned that, concentrate here. The voltage flux adjustment means potential coil flux adjustment of a certain single phase 220 volt induction whatever meter is altered so that the phase angle between applied voltage and flux due to it, applied voltage and this applied voltage and here flux due to it is 90. Actually, sorry, instead of 90, 85 is, it means directly delta he mentioned as 85 degrees. Okay, he is asking error in both the cases. First case, cos phi is equal to 1, phi is equal to 0. Cos phi is equal to 0.5. Therefore, phi is equal to 60. Phi is equal to 60. Okay, right. What is that? See the options. He is asking in which format? Watts notation or percentage? Watts only means he is asking watts. What is that? Vi sine delta minus phi minus cos phi. So I told you all values are given. Kindly don't give the wrong answer. Delta minus phi minus cos phi. Shiva Gopi Raju, Chaitanya Kumar, kindly check your answers. You will be getting minus 4.2 watts here, minus 85.1 watts here. Actually 4.18 something will be there, no problem. Right? Three-phase energy meter separately will be there. That is not in syllabus, don't worry. Separate three-phase energy meter will be there. Three phases will be there. That is different. Right. I will do this, concentrate. So, the meter constant of a single phase 240 volt. The meter constant of a single phase 240 volt induction whatever meter 400 revolutions per kWh. V is given as 240 volt. Meter constant is given as 400 revolutions per kWh. The speed of the meter disc for a current of 10 ampere, power factor of 0.8 lagging. Is asking what is the speed. Very, very simple here. If you stand with respect to the units, answer will be there. I'll tell you, concentrate here. Sir, I would like to find out energy first. I would like to find out energy. What energy formula? V into I into cos phi into time, power into time. So what is that? Voltage 240. Current 10. Cos phi 0.8. So V into I into cos phi, you will be getting in watts. Simply I'm dividing with 1000 to get kilowatts, into. So in this entire question, time is not mentioned. But in the options he has given that time is how much? RPM, revolutions per minute. What is it? Revolutions per minute. So therefore, 1 minute. Sir, if you take this one, kilowatt minute will be there. But what we require? kilowatt hour will require. So therefore 1 by 60 kilowatt hour. But 1 by 60 hour, this is time, this is kilowatt hour. Clear? No. If you simplify this, you'll be getting 0.032 kilowatt hour. 0.032 kilowatt hour. Clear? Okay. Sir, after this, in this loading condition, how much is the energy consumed? 0.032 kilowatt hours. What is a meter constant? Simply 1 kilowatt hour gives 400 revolutions. What is it? 400 revolutions per kilowatt hour. 1 kilowatt hour gives 400 revolutions. 0.032 kilowatt hour gives dash many revolutions. So you'll be getting, therefore n is equal to 12.8 revolutions anyway per minute only. So therefore answer is 12.8 R. Clear? Come on. Got it? Yeah, many people give the answer A. Minute is not given. Minute is not given. So therefore, what is it here? Options, revolutions per minute, revolutions per minute. So therefore, by the option only we can say that too. Speed basic unit itself is RPM, revolutions per minute. That's what the point. Okay. Again, people are asking, sir, RPM is not given. This is the multiple choice question. They will give, no need to worry. Suppose if it is given as numerical answer type, no need to worry. Standard time, if nothing is given, you have to take 1 minute only. The speed must be in RPM. Otherwise, even if it is fill in the blanks, they will give like this RPM. Then only we can answer. Otherwise, which time is to be taken here? Controversial. So that's why one we have to take. Right? Okay. While I'm explaining, if you listen, you can understand, Prakash. While I'm explaining, if you listen, it will be understood. Right? Now, let me take one more question. Right, sir. A 230 volt, 90 ampere, sorry, 10 ampere, 230 volt, 10 ampere, single phase energy meter makes 90 revolutions in 3 minutes at half load, comma, rated voltage and unity power factor. If the meter constant is 1800 revolutions per kWh, then its error at half load will be, dash. At half load, he is asking the error. See, I'm requesting everyone not to try for this question, Kindly listen carefully, because in this small logic is there. Mostly people are missing that logic. Yes, answer will be somewhat deviated. Kindly concentrate. Right, concentrate here. See, meter constant is given 1800 revolution per kWh. So in this, what I'm doing, concentrate here. Energy true value I'm finding. What is energy true value? V into I into cos phi into time. Okay. What is V? 230. What is I? 10. Power factor is UPF 1. Okay. Now simply 1. Right? Why I have taken 1000, to make it into, to convert that into kilowatt. If you are getting confused with the simple mathematics, no need to worry. Simply leave it. Into how much time? 3 minutes. He mentioned 3 minutes. So therefore, if I'm taking 3 minutes, what will be there? This one. This is watt minute. But what we require? Kilowatt hour. How do we do that? 230 into 10 into 1 by 1000. This watt becomes kilowatt. 3 minutes is there, 3 by 60 hours will be there. That only I did here. Those who told it is not clear, I revised it. What is it here? V into I into cos phi. Watts by 1000 kilowatt. 3 minutes, 3 hours, 3 by 60. Okay, you will get something. You will get something that is kilowatt. Leave it. Don't find out. Leave it simply. Sir, energy measured I'm taking. Sir, how do you get energy measured? How do you get energy measured? Right? Energy measured means the rotation based. How do you get the rotation based on which one here? Meter constant. So based on this only, the energy meter rotation we can take. That's why 1 kilowatt, 180, what's it? 800 revolutions. Is that no? Otherwise, in our experiment, how many revolutions are made by the disk in this experiment here? 90 revolutions. Therefore, what is the logic here? Sir, 1800 revolutions are made, then it will show 1 kilowatt hour. It will show 1 kilowatt hour. If 90 revolutions are made, if only 90 revolutions are made, then it will show how much value. Very simple. That's why based on the meter constant only, meter reading, I told in the yesterday's class also, based on the meter constant, number of revolutions by corresponding rotations of the gear is there. No, yes, based on that meter constant only, the reading will be indicated by the reading will be shown by the meter. Reading will be shown by the meter. So therefore, concentrate here, sir. 1800 revolutions, 1800 revolutions gives 1 kilowatt hour. 1800 revolutions give 1 kilowatt hour. Okay, how many revolutions are made? 90 revolutions are made. Sir, 90 by 1800. So many kilowatt hours. It will be equal to 0.05 kilowatt hour. Okay, assume that here some x was there, something x is there. Okay, now I'm finding therefore percentage error equal to percentage error equal to what is the formula? Right, what is the formula? Energy measured minus energy true by energy true into 100. Kindly have patience. Very, very important, very, very keen role here. Energy measured. How much? 0.05. Okay, kilowatt hour will keep outside. This is x by x into 100. Whatever you are getting, that is so and so error. Is it correct or wrong in this question? Is it correct or wrong? If it is wrong, where we have taken wrong? Where we have taken wrong thing. If it is correct, okay, tell me the value. Is it correct or wrong? Very good, very good, very good, very good. Right, right, right. Correct. Yes, very nice. So that's why. Okay, okay. Stop. Kindly concentrate. I'm going the reverse way for clarity purpose. Sir, percentage error at half load he is asking. So what you require? Energy measured at half load. Energy true at half load. Energy true at half load. Okay. So every value at half load you require. That's why. Let us come back now. Energy true at half load. Energy true at half load. What is meaning of half load? Half load means which one here? 10 by 2 because the full load current, that is what? At half load means the 10 amperes is full load, but he is asking half load. Therefore, 10 by 2. Just for clarity purpose, 10, otherwise you can take 5. Now you will get the value as 0.0575 kilowatts will be there. Now successfully we have calculated energy true at half load. Okay, happy. Now come back. Sir, in the true value we have made half load condition. Sir, what modification we have to do in the measured notation? What modification we have to do? Come on, guys. We made load means current, so that we made load by 2, 10 by 2, half, so 5, so over. Now, what modification we have to do here? Come on. Come on. Like many people give it. No modification. Very good. Very good. Nothing. Very nice. Okay. Few people multiplied by 2, divided by 2. Okay. Okay. Come on, guys. There will not be and there should not be any modification. There should not be any modification because concentrate. Sir, now I'm underlining 90 revolutions in 3 minutes. At which load? Half load directly given. That's why if you are taking 90 revolutions means that is half load only. As it is, we have to take no modification, nothing. Don't say that here by 2 is in, here full load is there. That's why we are taking by 2. But here half load is directly given. Half load is directly given. That is the reason. What is that? 90. So therefore automatically 90 by this 0.05 as it is. So that's why now we have to say here 0.0575. Right, you will be getting the value as minus 13.04%, minus 13.04%. Got it? Clear, guys? Okay, but see the options now. Sir, minus 13.04 is not there, but 13.04 slow is there, 13.04 fast is there. Which is correct? Means concentrate. This is the true, this is the true value consumed, but this is the measured value means shown by the device. If this is the measured value shown by the device, what does it mean? Concentrate. Measured value is less than the true value. Sir, measured value is less than the true value means the speed of the disk is less than the true value. That's why we can write this as 13.04%, comma, slow, right? But don't keep like this. Don't keep minus and slow both. What is it here? Minus and slow. It implies minus of minus means it becomes fast. So that's why either minus or slow, anything must be taken. Don't keep both. If you're keeping both slow and slow, reverse, simply it become fast notation. Right. Gautami, it is not fast here. Sai Charan, it's not fast because I'm coming again. Measured value is low. True value is more means we are utilizing more, but bill is less means speed is less. That's not the point. So therefore it is slow only. Got it? Those who are given fast, Sai Charan and Gautami. Right. Okay. Like this, so many questions we are going to solve. One by one, we are going to solve so many questions. Very good. Yes, so fast. Very nice. Very simple. What he is asking? A single phase energy meter is operating on 230-volt 50 hertz supply with a load of 20 ampere for 2 hours at UPF. The meter makes 1380 revolutions in that period. The meter constant is very, very simple. See, what is a meter constant? Revolutions per kWh. Revolutions are there. So what do you require? kWh. Revolutions by kWh. You kindly. So simply energy true equal to energy equal. What is that? V 230 into 20 into cos phi. What is that? VA cos phi 1 into time is 2 hours he has given. So 2 by 1000 by 1000. What is it here? You will be getting some value. Clear? You will be getting 9 point, right? How much you are getting? 2, 9.2 kilowatt hours. Okay, after that, simple. K equal to number of revolutions by kWh. So revolutions per kWh. What is it? Simply 150 revolutions per kWh. Right? Clear? Clear, guys? Right? Okay, now, next one more question. Try this. Make it fast. Very nice. 1380. Very good. Very good. Energy meter is very simple. Yeah, that's what. Very nice. Very nice. Yeah, many people give that 1380. What is it? Ke is given as 200 revolutions per kWh. What is asking? Revolutions. Very simple. Again, same notation. What is that? energy is equal to 230 into 10 into UPF1 by 1000 into how much time? 3 hours. You'll get. After that, what is it? K is equal to, what is it? 200 revolutions per kWh. Right? Okay. 1 kWh is equal to 200 revolutions. Then what is this kWh here? What is kWh? 6.9 kWh. So 6.9 kWh is dash. So therefore 1380 revolutions. Same model, but data is different. That's it. Right? Got it? Right? Now, let me take one more question. Come on. Very simple one. Very simple one. Very good. 200. Very simple. 200. No need to write anything. Simply here. 1200 revolutions per kWh is found to make 5 revolutions in 75 seconds. And the load power is dash. Very, very simple here. Here. Sir, 1200 revolutions give 1 kilowatt hour. Gives 1 kilowatt hour. Okay. And 5 revolutions gives dash. What is that? 5 by 1200 kWh. This is energy. This is energy. Okay. After that, power is equal to energy by time. 5 by 1200 kWh by how much time? 75 seconds. But we need to have hours. So 75 by this. So hours will be cancelled. You will be getting 0.22 kilowatt. Nothing but 200 watt. Madhavrao, where you are not understanding. Nothing is there to here. What is it here? 1200 revolutions is giving 1 kilowatt hour. 5 revolutions dash. So simply 5 revolutions by 1200 cancel. kWh will be there. After that, power equal to energy by time. That's it. Yes. Very good. 0.2 kilowatt, 200 watts. Very good. Very good. If you are able to concentrate, definitely it will be clear. Very simple questions. That too, I'm not at all going fast also. I'm giving time to you. I'm giving time to you. 1 second. Take this question as the homework question. And tomorrow class, I'll give you the answer. Kindly don't ask me answer. I will give you. I'll give you definitely. So take this as a homework. Right. Now, I'm concluding this energy meter by taking a last topic in this, that is phantom loading in energy meter. Phantom loading in energy meter. Right. So what is a phantom loading? First of all, the meaning of phantom loading itself is the meaning of phantom loading itself is fictitious loading. Fictitious loading, we can say. Nothing but this is called as imaginary loading. Fictitious loading or imaginary loading. So what is the meaning of this? In yesterday's class, I told you 1 kilowatt. 1 second. Yeah, 1 second. In the homework question, 1 second. Yeah. This is 138 seconds. I forgot this. 138 seconds, not 1385. This is 138 seconds. Very good. Who is this? Right, Gagan. Very good. Thank you. Yes. 138 seconds it is. Now you can proceed. Okay, right. You identified that, okay, but you are not listening, it seems. This one, kindly concentrate. Fictitious loading. Okay, right. So what is that fictitious loading? What is that fictitious loading? Means that is called as imaginary loading. So what do you mean by this imaginary loading? Means in the yesterday's class, I told you in the entire energy meter, right? This is the energy meter. Here some load is there. I gave you 1 kilowatt is connected. For 1 hour of time, they observe some number of revolutions based on the meter constant is set by the manufacturer. I told you meter constant is set by the manufacturer. I told you. So that's what the point. So therefore, sir, 1 kilowatt load is okay, but how do we keep 1 kilowatt load? Do we keep actual refrigerator as the load? Do we keep actual washing machine as a load? No, those are called as actual load. But this is fictitious loading, means imaginary, means we don't keep the actual load on the corresponding system, because this is under testing. If this is under testing, do you keep directly fan? Do you keep directly AC over there? No. Why? Means this is under testing. This design is not yet completed. We are testing the device working properly or not. So that's why during the testing, actual loading should not be used. During the testing, actual loading should not be used. If you are using the actual loading, what happens here? Actual loading losses will be occurred. Suppose if you are using the washing machine, means some function should be done. But for what purpose you are using? Only for testing, means unnecessarily in the washing machine loss will be there. No, if washing machine is switched on, means our cloth must be washed. But here, what is it here? Simply for testing purposes you are using. No, that is the reason why what you have to do here, actual loadings we should not keep. If you are keeping the actual loadings, actual loading losses will be occurred. That's why always be clear. Not only this, any testing you take in your entire machine lab, whatever the experiment you took, right? Did you keep actual load over there? Did you keep any fan over there, AC over there, any other refrigerator like that, etc.? No. What did you keep? Resist to load box we have kept. We did not keep any bulbs, fans, or incandescent bulbs, or tubelets, etc. No. Only the thing is which one here? Resist to load, means that is equivalent to our load, that is called as imaginary load, we say. That is called nothing but fictitious load, we say. So that's why in order to test the energy meter, not only energy meter, any machine, imaginary load only. That's why in a DC machines, no load test. Full load test means blocked rotor test. Based on that, at half full load, what is that calculation we do? At 1/4 full load, what is that calculation only we do? By taking I by 2, I by 4, I by 3, or I by 2, like that. I by 3, I by 4, etc. That's why we need to go for, what is it here? Fictitious loading only always. Okay. But in this phantom loading, how do we conduct the test? How do we conduct this? Means how do we give the fictitious loading connection? Means concentrate here. This is our energy meter. Look, 1 second, I will draw it here. See, this is our energy meter. Which one? Shunt magnet. Here, series magnet means current coil circuit will be there. Sir, what is the procedure? Construction I'm giving. Construction procedure. What is that? Simply, potential coil must be connected to nominal supply voltage. Potential coil must be connected to nominal supply voltage here. Nominal supply voltage means generally we say 230 volt. What is the nominal supply voltage in our house? 230 volt. We give nominal 230 volts directly. But sir, this is the procedure here. Now to the current coil, we give small voltage source, very, very small voltage source, and rheostat in this, or rheostat, and path is closed. What we do, suppose I want to keep 1 kilowatt load for 1 hour. That's not a task. 1 kilowatt load for 1 hour means 1000 watt hours we should get. Assume that I will be giving 250 volt. For example, 250 volt. I will be varying, concentrate here. I will be varying the rheostat until, suppose ammeter we can take here. I will be varying the rheostat until the ammeter shows 4 amperes. Once it is showing 4 amperes, 4 ampere will be there. This entire thing will be given for 1 hour of time. So 250 volt into 4 ampere, 1000 watt. 1000 watt means 1 kilowatt conducted for 1 hour. So automatically, in this case, how many revolutions are made by the disk? They will count like this. Now tell me, in this, are we using any actual load anywhere? No, we are not using actual load anywhere. So that is the reason why this is called as fictitious load. And that too, in your lab, I don't know in whose laboratory, in whose university is there. In the generally, in the Usmani University, generally in our state, I know that's one college I'm giving. But other universities, I don't know. In the JNTU, Hyderabad University, this experiment is not there. Right? But in the Usmania, it is about other state people, kindly, you recollect it. I don't know exactly. This experiment is there in the Usmania University affiliated or Usmania University curriculum. That is, what is it? Phantom loading means potential coil is connected to the nominal supply voltage directly. Current coil is connected with, what is a small voltage source along with the rheostat. After that, this is a construction. Operation is by varying the rheostat. What we do, by varying the rheostat, actual loading conditions will be occurred. By varying the rheostat, actual loading conditions will be occurred. Right? So therefore, this is what the point I'm writing now here. Potential coil is connected to nominal supply voltage. Potential coil is connected to nominal supply voltage, right? And current coil is connected with a small voltage supply, connected with a small voltage source along with the rheostat. This is called as fictitious loading circuit diagram connection. Circuit diagram connection here. Sir, you are given light bulb loads. Yeah, that is okay. That's why actual load means heavy load. Generally, we don't give bulb or resistor. That is okay. No problem. No problem. But we don't keep the heavy load. It may be getting disturbed. So that's a small bulb inconsiderable. No problem. No problem. Right? This is the construction. No, very, very simple operation. What is that? By varying the rheostat, by varying the rheostat, actual, by varying the rheostat, actual loading condition is obtained. See, actual loading we are not placing, but actual loading condition, actual loading equivalent circuit condition is obtained. That's why actual loading condition is obtained. This was the point. Actual loading condition is obtained. Sir, by doing so, what we are going to achieve? Right. See, why taking supply separately means that is what the see input supply you have to give here. This is the total. What is that phantom loading experiment? Why we are taking means come on here, Bhavani here. This is the procedure. Normal 230 volts we have to give, but to the current coil, no need to give the 230 volt. No need to give the corresponding what is that here full load or etc actual load. The experimental setup itself is separate source, here also separate source, but it is not a big deal of getting the two supplies. No, the experimental setup itself is two things. That's not the point, so don't worry. This is the experimental setup. Kindly don't get confused like why and all. Kindly don't worry, don't worry. This is the experiment. Suppose simple logical in Hopkinson test of DC machine. So Hopkinson test means two machines must be used. So why two machines means that is experiment setup. That's why be clear, don't get confused. Right? Okay. Due to this, what is that here? Due to this, actual loading losses, due to this actual loading losses can be eliminated. Due to this actual loading losses can be eliminated. That's what the advantage of this one. Right. Why can't we coil the current coil as PC? Is it possible if it does? No. Be clear. Current coil means less number of turns. Potential coil means more number of turns as it is. This is the procedure. Potential coil with full voltage, 230, etc. Load means we are talking about the loading condition. Load means current. So therefore, current must be minimized. Current circuit must be minimum supply. So therefore, we are taking this one. Don't interchange this. Actually, potential coil and current coil we cannot interchange. We should not interchange because dimension is different, capacity is different, everything is different. That's why potential coil, I told you already in my discussion, more number of turns will be there. Current coil, less number of turns will be there. Clear? Be clear. So this is the total discussion. Clear? Now, finally, I'm giving conclusion in this. What is that? Direct to loading test. Direct loading. Here, phantom loading. Now I'm comparing these two. I'll prove also how we are saving the energy and all I'm giving. Yeah, see for simplicity purpose always we take resistive load only. That's why I kept here resistive element. For simplicity purpose in the experimental analysis always we prefer resistive load only. No problem. Right, now be clear guys. I'm drawing the diagram again for clarity purpose so that formula will be very simple. One second. Right here, potential coil, nominal supply voltage V phase means our 230 normally. Here current coil, here small voltage source. rheostat, and ammeter, right, will be there for measuring the current like this. This is small rheostat. Okay, right. Now, in this, what is the energy meter diagram? Right? How was the circuit here? This is the supply given to the load, current coil, and supply here. Okay. After that, potential. Rough diagram I'm giving, just rough diagram. This is PC, PC, CC, CC. Clear? Right. Now, sir, across the load VL, through the load IL, this current is IC, this current is IP. Here anyway, V phase. Okay, right. See, so what is the loss in this? Power loss in the entire instrument. In this also, what is the power loss? Very simple. Power loss means power loss in the potential coil, power loss in the current coil. That only we take it. Power loss in the potential and power loss in the current coil. Sumasri, which one you are asking? What is T-shaped coil? Where is the T-shaped coil? T-shaped coil is not there in my diagram. There is no T-shaped coil at all. Did I draw? Right. Here, P loss means power loss in the potential coil, power loss in the current coil, power loss in the potential coil, power loss in the current coil. Now, very, very, very important. Sir, what is the power loss in the potential coil? Check it here. Sir, V, I'm talking about active power notation only. Here, V square by this entire resistance. Loss means consumed power. So therefore, V phase square by RPC. Potential coil resistance. So why not inductance? Why not inductive reactance? I am asking about loss component, not the stored one. Loss means power consumed one, etc. Here, what is power in the potential coil? Same thing. V phase square by RPC. V phase square by RPC plus. So what is the power loss in the current coil? Check it here. Sir, in this entire thing, what is there? Load resistance RL is there. Load resistance RL. Okay. And here, current coil resistance also there. Therefore, across this entire combination, load resistance simply I'm taking as R, for example. R is there, RCC is there. Across this combination, how much voltage here? V phase. So therefore, V phase square by R plus RCC. V phase square by R plus RCC. But in this, here, this is small voltage source. V am taking. So therefore, this is applied. So V square by R plus current coil resistance RCC. Actually, this R and this R, we are assuming as same only. Why? This is the actual load resistance. This is the fictitious load resistance. Your condition is same. Now check it here. V phase square by RPC. V phase square by RPC. Same. Leave it. V phase denominator R plus RCC. R plus R denominator also same. But numerator V is very, very small. 5 volt, 10 volt, 20 volt, 30 volt will be there. But here V phase is directly to 30 volt. Now tell me, in which case we are having more power loss, means in this case power loss is more, in this case power loss is less. With numerical, already concept I gave you, but with the numerical point I gave you here again. Right? And few people are asking that, come on here, this is the core. This is the core. It is not the coil here. It is the core. Actually, we say E type of core. Why, etc. The design is not required. Here we are keeping coil on this. This is the coil. This entire T shape is core, not the coil, not the coil. Where we have to keep the coil means on one core. Yes, this is what the core. And here, C shape of core will be used generally. And here, like this, right? This winding is nothing but coil, but this entire C shape or this entire E shape or T shape, that is core, not the coil. That is core only, not the coil. Be clear. Clear? Now, are you able to understand what is the difference between these two? Where we are having more and where we are having less error? Yes, in the phantom loading, less error. Right. See, Vamshi, the phantom loading itself is this one. Potential coil and current coil both are not together, but potential coil V is there, current coil I is there. V into I into cos phi. Yes, energy will be there. No need to worry. That's why this is only for testing. Means the disk is root. Everything is same. Same thing. Phi P will be there. IP will be there. Phi P will be there. IC, Phi C. Everything is same. But only there direct load, here fictitious load. That's it. Don't think that these two coils must be connected together. No, in the normal practical operation we connect like this, because actual load you connect over there after designing the device properly. But now whether the instrument is designed properly or we don't know. That's why we are testing. That's why this is the testing process, right? See, Anurag Raj, in our energy meter, see, kindly try to understand. If you ask this type of question, I'll be feeling like I'm not at all clear to you. The question is, in energy meter in our home, has phantom or direct loading? What is this question? This is testing purpose, whether the energy meter is working or not. Testing purpose in your house, actual load is placed here. That is direct loading only. Try to understand the terminology here. After completion of entire story, you are asking that basic point only. I'm not saying don't ask, you should ask, but before asking you need to think. No, yeah, okay, direct loading means normal loading in our house. Are you testing the energy limit in our house? Not testing. Yeah, that is direct loading only. Right. Could you explain how potential coil of CC equal to V phase? Who told that potential coil of CC? What is it? Potential coil of CC. What is this terminology? Ashwin Prasad, could you explain how the potential of CC equal to, okay, potential of CC equal to V phase? Who told that potential of CC equal to V phase? Who told? Did I say that? Come on here. Did I say that this is equal to this one? Come on, what are you understanding here? This, both are same. Denominator same. Here this is less voltage, this is more voltage. That is the reason why our loss in the phantom loading is less. Loss in the phantom loading is less. Concept I gave, due to this actual loading losses can be eliminated. Yes, I proved that this is very less value, this is very large value. That is the reason why we are able to reduce that loss. That is what the point. This is only for testing purpose, whether it is working properly or not, right? Srinath, kindly have minimum thing before asking. V power means I can take I square R, V square by R. If I take I square R, why can't you take V square by R? If I take V square by R, why can't you take I square R? Come on here. If I give I, you can write I square also. Nothing wrong. Nothing wrong at all. Only one of the formula I've taken, no, yeah, right? Any formula you can use, no problem. One of the formulae I'm taking so that I can clearly explain that this V, different I explain. If I take I square, how can you say that both are different? That's not the main point. Right. Concentrate here. Again, you are not at all understanding. Today, what happened here? Today, actually, holiday, but I have taken the class. That's why you're not listening, it seems. Come on, yeah. How to, I already told the first point only in the energy meter. In the energy meter, right? What I told you, we keep 1 kilowatt load, 1 kilowatt load for 1 hour, 1 kilowatt load for 1 hour. Then the people will observe 1,000 revolutions, for example, based on the 1,000 revolutions per kWh, they will set it. But which load we keep? Which load we keep means phantom loading we keep. That is what testing, designing, constructing, manufacturing, everything is same. Here, small voltage source, rheostat, by varying the, just I told you, 1 kilowatt or etc. I told you, by varying this, right? 1 kilowatt they will set. Given for 1 hour, they will observe the, what is the disk revolutions. Disk revolutions are 1,000, for example. They will set that 1,000 revolutions per kWh. This is during designing or during operation, means during designing only. That only we do experimentally in the laboratory. That's what the point. Clear? This is a total discussion regarding energy meter construction and operation totally. That's why if you listen carefully, step by step, I told you, first point I told you here. What is that? Fictitious loading. I gave you the diagrammatical also. 1 kilowatt load connected for 1 hour. I told you in the yesterday's class. But how do we keep the load? Means not directly, because we are in the designing stage only. That's why normal resistance is placed. I give this point also. This numerically I wanted to give you. That's why I have taken this procedure. Clear? Yes, one student told that, asked that, why not R I square, R plus RCC? I can take, but I cannot compare this with respect to this. So that this is less, it will be difficult to analyze formula wise. Mathematically, okay, formula wise. So that's why I have taken V square by R notation. That's it, nothing more than that at all. At least now how it is clear. Clear, guys? Can you respond at least now? Right. Now, let us have one question on this to have better clarity. Yeah, we can minimize the losses by doing the phantom loading. Which losses? Actual loading losses, not the error. Energy meter constructed, so working properly or not, that we are testing. Simple logic here. Suppose one bike is manufactured, whether it is working or not, that will be tested in the laboratory, or that will be tested by the human being. If the human being is driving, some problem is there, damage will be there, some mysterious things will be happen. Suppose that entire bike kept in the workshop and they are testing but working properly. In this, what you are doing here, you are analyzing the meter such that, okay, actual loading losses are eliminated, but by keeping the imagined load, you are saying that, okay, bike is designed properly, or any modification like that, they will test it. That is what the meaning. Resistive load means unity power factor. Already told you, unity power factor. Just for clarity purpose, I'm taking only phantom loading definition, that is enough, but safe side I'm giving. Concentrate, I will do this. A 220 volt 5 ampere energy meter is tested at its marked ratings. Okay, RPC given as 8800 ohm and RCC given as 0.1 ohm. Calculate the power consumed when testing the meter with phantom loading with current circuit is excited by 6 volt. Battery means supply 6 volts. Check it here. Normally 220, but here 6 volts. Normally 220, but this is excited by 6 volts because the phantom loading itself is what is it here? Very less, what is that, less voltage must be applied to the corresponding structure. Okay, right. What is that? Totally what he is asking here. Calculate the power consumed when testing the energy meter with phantom loading. Concentrate. So what is that? With phantom loading, power consumed with the circuit. So power loss is equal to power in the potential coil, power in the current coil. Power in the current coil. Concentrate here. What is the potential coil one? V square. What is V square? 220 square by RPC. 8,800 plus. What is the power in the current coil? Now, one student asked that, sir, why not I square R? One student asked, no, you can use I square R, you can use V square R, you can use V into I also, no problem. But to compare this and this, I gave you this. Now here, sir, in this current coil, what we can write? I square R plus RCC. R plus RCC. Clear? Right? After that, we can use V square by R plus RCC. Okay, but in this entire thing, RCC is given, load is not given, means R is not given. So can we use these two formulae? No. If you are unable to use these two formulae, so what is the ultimate formula we can use here? Simply voltage applied to current coil, current flowing through the current coil over. That's why V into I square R, V square by R, anything, but according to requirement, you have to use it. That's it. Therefore, what is that? 220 square by 8,800 plus VCC, voltage applied, 6 into I. What is it? 5. 6 into 5. What is the total value? Tell me. Aishwarya, 316.8 kilo. What is that? You'll be getting, this is 30, this is 5.5. So answer is 35.5. Very small amount of power. Yes. So this is a total discussion regarding complete information regarding energy meter. Complete information regarding energy meter. Clear, guys? Now, many people ask that, so how to reduce the speed and all. Many people ask me, but be clear, these are the questions possible in interview also. Interview also. Very. That's why I'm giving all this. So many people told that, sir, we kept the magnet. I kept the, so don't keep the magnet. Don't keep the magnet. Of course, nowadays you cannot keep also. See, kindly concentrate. Many people are eagerly waiting for this that I'm giving now. Open in the classroom, I'm giving this because you cannot do at your home right now, right? In the nowadays, you cannot do at your home. Gurukonda Satish, before asking, try to understand. I gave you already why we are unable to use V square by R formula. All I told you, go back to the video and watch it. That's why I say always, I explained, clearly explained two formula I gave you. I square R, I square into R plus RCC. Load resistance is not given. So therefore we cannot use. V square by R plus RPC. R is not given. That's why I told you just now, just 2-3 minutes back only, I told you. Why can't we use again the same question? I told you that already it cannot be used in this. Right. See, or come on, Sai Charan Reddy, no, 5 amperes is potential coil supply. Now, come on here, 5 amperes means current coil, 220 means voltage. Always the current will be related to current coil or load notation, voltage will be related to supply voltage. Be clear. Yeah, you should not miss the point. That is what my headache actually. Sorry, sir, I missed the point. Okay, I'm not expecting any sorry from you. I'm expecting not only you, Satish, anyone, everyone. You need to listen carefully. This is the main problem with this class because You're at your home, definitely. Therefore, you're talking to someone, etc. 1 2 minutes, topic will be missed. Again, immediately you are not having that thought also. I missed it. I should not disturb the class. In that, you're not thinking. Immediately posting the question. Arey, why did you miss? You did not listen. Isn't it? So what you have to do after the class, recorded video is there, you understand. Okay, even after listening, if anything is missing, you can openly ask, you can ask, no problem at all. But by missing something, by doing something, etc., etc., you're at home, you're at relaxing position. So that's why all these problems. Clear? Right? Now, here, this is the energy meter. Actually, energy meter will be like this here. This is actual structure. Terminal box. From the service line, 2 wires will be coming. 2 wires will be going into our home, hall, kitchen, etc., etc. Internally, so many coils and all will be there. Okay. Earlier, long back, 10 15 years back, kindly consider this is the practical idea. Intentionally, I wanted to give you because in the interview, these type of questions may be asked. These type of questions may be asked. Yeah, olden days. Actually, nowadays almost all the meters are replaced with digital mostly. But I'm giving concept point of view. Disk-based energy meter is there. Permanent magnet is there. Disk is there, like this. People means we generally used to keep. Can I requesting? Don't try. Of course, you cannot try. Here, permanent magnet the people used to keep on the top of the corresponding box. But actually, here in the olden days, in the olden 10 15 years back, the energy meter was like this. Like this. This is the entire thing is black color material, and this is the glass particle, transparent. We can see the meter reading, and we can see the disc also like this. Okay, this completely metal content, iron type of content was there actually, and people used to keep permanent magnet, sleeping happily during the night, right? So during the night by switching on AC, of course not AC at that time, but all the fans, etc., etc., they used to switch on. Why means concentrate here, concentrate. See, kindly don't do that. Kindly don't do that. Here, permanent magnet is there. Yes or no? This magnet we are keeping from outside. So external magnetic field disturbs the internal magnetic field. Therefore, this internal magnetic field is getting disturbed. Therefore, the speed will be disturbed. Happily sleeping at the night, morning removing the permanent magnet. By doing so, what happens, sir? The corresponding speed will be disturbed. Automatically, the meter reading will be less than the normal. Meter reading will be less than the normal. This was the first point. Okay, this general thing. Second, one more thing. People used to do all these things people used to do. Right? Now, one more thing. Sir, this is the black color material. This is the glass content. People used to cut here. People used to cut here. Only just one break. Right? In that break point, they used to insert films. Negative, we can say. I hope you can understand. Films are negatives, we can say. Before this digital cameras, real camera was there. I'm talking about that reel. They used to insert from bottom to top or side, etc. They used to insert through this, right? They they, they did not break this entire thing. Simply through this entire small shortcut, and in that they used to insert. What happened, with this film, right? Suppose this my hand is disc, for example. This is the film, right? It is placed near to this. Means as a disc is rotating and touching this film, automatically due to this friction, speed will be reduced. Of course, very small quantity, but it is reduced. By doing these two methods, the speed of the disc can be reduced technically. But one more method is there. One more method. Here, why I'm saying this, after entering into your field, in your future, in the job field, for example, you are going to inspection, for example, inspect the things. You must be able to understand what misuse things the people are doing. That's why intentionally I'm taking all this. Of course, people already, before starting energy meter only, one student asked how to stop the energy meter. Let us start first. That's why I completed. Now I'm stopping now. Okay. Next, third one. This is very, very dangerous method. This is very, very dangerous method. That is what? Here, this is phase, neutral. Assume that this is phase, this is neutral, for example. Phase, neutral, like this. For example, actually, olden days means 10, 15 years back approximately. This terminal box, right? Free to open. There was no seal at that time. Free to open, right? Simply people used to open this cap and simply technical point. See, here to here, what is it here? Small wire, small piece of wire they'll be taking it. They used to connect from here to here. What is that happening? This is very danger here. What is it? So far in the other two methods, you allowed the energy meter to take the supply. But in this case, you are not allowing the energy meter to take the supply at all. Why? The current is coming here. Here to here, current always flows in a shortest path, short circuit path. Yes, simply major current will be flowing this because only a piece of wire, only small current will be flowing to the entire energy meter. Due to this, the speed will be reduced to much more minimum value. Thereby, automatically, the current will be less only. So these three were used generally. That's why the electricity board was so much of loss at that time. That's why they decided to here not to keep the energy meter inside the home. Now I hope every energy meter is outside your main door, isn't it? Plus that is sealed one. The two nowadays digital one, so you cannot do anything. So don't try, don't waste the time. But you need to understand the concept. That's it. For that purpose, I gave you. Right. Vishnu Ajit, that is ethically wrong. Don't do that. Right. So this is the main problem. This is the main problem. We are the electrical engineers, so that we should follow the electrical rules compulsory. Only these methods I'm giving. Other methods don't have. So many methods are there, but only for idea purpose, I give you this. That's it. Okay. This is the total thing related to energy meter. Yeah, very good, very good. It is safe. That's why openly I could answer in the class all these. But when we were in the college, my faculty told that please better don't do, please better don't do. By saying this, he explained. But now I cannot. I need not to see because you cannot do because nowadays you are having digital meter. That too, those meters are available outside your home, so no problem at all. I'm requesting everyone, don't ask more than these three questions. I'm requesting. Actually, I should not say, but even though I tried to manage, so kindly don't ask other than these two. How can we do? How can we that, etc., etc., etc. Don't do that. Don't ask me kindly. Only for idea purpose, I told you. Yeah, Sanjay, that problem is also there, but people don't know, right? That's what the point. Clear? Right. This is the total discussion regarding energy meter in detail, step by step, all sorts of questions, including numericals, I have done. So kindly practice more. Concept completely done yesterday, only today. Only the thing is how to test the energy meter means generally phantom loading, resistor loading only UP because resistor means rheostat loading means automatically resistor load only we can see. Clear? One second. right? Now, after this lengthy chapter, power, measurement of power and correspondingly measurement of energy and all, now I'm taking a small topic. What is DC potentiometers? Very small topic. DC potentiometers. Right now, sir, what is this DC potentiometer? Sir, already potentiometer means potential measurement of nice, right? DC potentiometer. Potentiometer means it is a voltage measuring device, potential measuring device. So that's why the first point here is voltage measurement. Kindly concentrate. Voltage measurement. So many people asked about this device at the time of starting classes. I told you this device will be taken later. I told you. Now I'm giving that application. Kindly concentrate. That's why everything will be covered, but time has to come step by step. I'll be doing. Kindly concentrate. Voltage measurement purposes. Sir, voltage measurement purposes, PMMC voltmeter is there, MI voltmeter, EMMC voltmeter, electrostatic, all those are there. But why or what is the significance of this potentiometer? Means this is a null type instrument. This is a null type instrument. Nothing but null indicating device, we can say. Null indicating device. Or we can say zero indicating device, a null type instrument, we say. Null type instrument. Clear? So therefore, what is it? DC potentiometer is a device which measures the voltage, but which works on the principle of null type, which works on the principle of null type. Right? See, Ashish Kumar, don't worry. Right? The syllabus is there for especially you people only. In the measurements, instrumentation that is added, I will be taking later. See, I'm saying only one thing here regarding the syllabus topics covered. Don't worry at all. Everything will be covered, everything, because the topic is not there for electrical people. Ashish Kumar, that is recently added. Last year we added. I will be taking to you separately. No need to worry. Everything will be covered. Don't worry, don't worry. But my point is, whatever I'm covering, you should be perfect in that. You should follow that. You should have the practice on that. That's what the point here. Right. See, I'm remembering your names. Whoever still typing regarding sir permanent magnet outside, inside, etc. I don't answer your questions in the doubt session also. Be clear. I'm remembering your names also. 2-3 people. Then who is typing? The still you is typing about still these. So how to take, how to magnet extra inside, outside. My house is there, our house is there, my friend house is there, blah 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 blah. Still people are typing. Right? Okay, now, sir, null type instrument, null indicating device. Sir, what do you mean by null type device? All I told this type of structure I have shown, but I'm taking elaborate application point of view. This is called as center zero scale. This is called as center zero scale, right? The example here is, galvanometer we use. Galvanometer. Galvanometer is a device. Galvanometer is a device which is designed as center zero scale instrument. Means right side some scale will be there, left side also some scale will be there. But unfortunate thing is galvanometer construction, operation, everything is not there. No need to worry. Only application is there. This was there long back. D'Arsonval galvanometer, vibration galvanometer, and so many types of galvanometers are there. So all the ballistic galvanometer like that meters are there. Those constructions and all not there nowadays. I told you already. 2003 and 4, sometime 2009 one time, 13 one time, 17 one time, 21 one time. So many times syllabus has been changed. Construction operation is not there. Don't worry. Only galvanometer application. But I need to explain galvanometer details clearly to understand the next coming topic. That's why galvanometer is a device which is designed as center zero scale. Center zero scale means the point here is it is able to it is able to respond in both the directions. One is right side, one is left side. For example, in one circuit, galvanometer is connected. For example, right? Suppose assume that left to right current is flowing. For example, here we can't guarantee, but assume that left to right current is flowing. The pointer is moving like this. For example, if right to left current is flowing, the pointer will move like this. Means this is the device which is having the capability to sense the current in both directions. It is the device to sense the current in both directions. But so far we have taken all those are one-way sensing. So that's why what are those devices? One second. Those devices are called deflection type devices. That's why I'm giving simple point here. Deflection type devices. Deflection type means all are these type of devices, 0 to full scale value. Okay, example, all the devices what you have seen so far, everything, ammeter, voltmeter, wattmeter, PMMC, all you have taken, everything come over here. But galvanometer means center zero scale, means this is the device which is having the capability to sense current in both the directions. That's why, how do we use this device? How do we use this device for measurement of voltage? Means, all I told you, the potentiometer is not the deflection type. Which type? Null type instrument. Means in the potentiometer circuit, the null type of device, that is galvanometer, is useful. With the help of galvanometer only, we are going to measure the voltages in this potentiometer. Okay, you may be asking, sir, already those devices are there. What is its importance? I will show one by one. Okay, very simple, sir. Here, this is known voltage. This is known EMF, some 10 or 50 something. Okay, this between these 2 points, A and B points, I am connecting my unknown EMF. Means I want to measure unknown. I want to measure the EMF at 2 points. Those 2 points will be connected between A and B. Nothing but unknown EMF. Clear? This is unknown EMF. Okay. How do we measure? Means concentrate. Negative is connected to negative in that way only. Positive is connected to positive with the help of galvanometer. With the help of galvanometer. Now, sir, if we don't know, if galvanometer shows 0, if the galvanometer shows 0, what is it here? If galvanometer shows 0, what does it mean? The current from known to unknown, unknown to known, both are equal and opposite. So automatically what we can say here, unknown EMF is equal to known EMF. Suppose unknown EMF is 10, automatically yes, known EMF is 10, automatically unknown EMF is 10 volt. Now tell me in this entire approach, do we have any device such that the pointer is moving from 0 to 10 and showing 10, therefore writing 10 like that? No, that method is deflection method, that is PMMC, MI, EMMC, electrostatic. But here, by the comparison method, comparison of unknown EMF with the known EMF, comparison of unknown EMF with the known EMF, we are getting the corresponding value measurement. That's why I told you the potentiometer works with respect to on the principle of null indication. Means, be clear guys, I'm repeating this point. In this entire device, we will not be shown as 5, we will not be shown as 2, or we will not be shown as 10.5 something. No, right? We will be observing 0 current in the galvanometer. After that, by the comparison process, we are going to obtain the unknown EMF. This is the overall introduction only. But this only elaborately taken, 1 by 2 devices are there. We are going to take elaborated discussion in the potentiometers. But what is it? Once the galvanometer shows 0, in this circuit, unknown EMF equal to known EMF. But immediately people are asking that, sir, if the galvanometer does not show 0, That is what the next discussion. Everything will be taken. That's why we try to make galvanometer value as 0. That's what the point. Clear? This small introduction. Take the break and come back. We'll continue the topic. Right. Come back. Right. In this, there are two types of devices in the potentiometers. Two types of potentiometers are there. What are those? First one, basic slide wire DC potentiometer. Basic slide wire DC potentiometer. Second one is DC Crompton's potentiometer. DC Crompton's potentiometer. In this, some different dimensions we can take, but in this, he has given Crompton's base. He has given some resistance wire. That wire only we have to take. That's what the point. Now, let me take one by one here. Basic slide wire DC potentiometer. Basic slide wire DC potentiometer. Sir, what is this? Everyone concentrate here. Sir, in this, the circuit is like this. Kindly concentrate. It is purely conceptual topic. After that, numerical will be there, but topic is purely conceptual. Here, known EMF will be there. This is known EMF, right? Known EMF. And some rheostat will be taken for having the changes in the current. To have the variable current, we are using this variable resistance. And one ammeter will be there. This is what the circuit diagram of the potentiometer. Okay. This and this. This terminal is A and this terminal is B. Right. Here you can take any dimension of the resistance for explanation purpose. I am taking one of the dimensions. What is it? I'm connecting one resistance wire, nothing but one slide wire between these two. I'm connecting one slide wire between these two. What do you mean by slide wire? Simply a very smooth, fine structured wire. And that if I want to move any wiper contact, it should be having the smooth movement like this. That is called as slide wire. Means the surface is very smooth, so that any wiper contact can be easily slided over that. Okay. Now, here, the point here is, sir, what is the length of this? What is the length of this one? Concentrate here. So length of slide wire, length of AB, right? For explanation purpose, I'm taking 200 centimeter, but generally this will be normally 200 centimeter or 150 centimeter or 100 centimeter, like that will be there. Not 1 centimeter, 2 centimeter. No, it will be generally large only. Why also will give you. Okay. Next, the resistance of this material I'm taking for example purpose is 200 ohm. Sir, why I'm taking like this? No, for easy understanding purpose, 1 ohm per centimeter. 200 ohm, 200 centimeter, 1 ohm per centimeter. Yes, this is constant. Definitely. 1 to 1 I'm taking. Sir, do we need to take 1 to 1 always? No. You can take 100 here. You can take 400 here, 500 here, 600 or 200 or 100, as you wish, any number, any number. So that's why one of the magnitudes only I'm taking. Kindly be clear. No one should get confused here. Why only these two dimensions? No one should ask. All I told you. What is it? 200 centimeters is one example. 200 ohms is one example. It may be 400. It may be 50 also, as you wish, as you wish. So that's why any number you have to take. So one of the numbers I'm taking like this. Only one of the numbers. Okay. After that, here in this entire experiment, I'm going to show testing of nothing but designing, nothing but calibration of the device. Calibration of the device means, yes, whether this slide wire is how we have to take the slide wire scale, whether it is working properly or not, etc. Designing stage we can say, calibration we can say, manufacturing we can say, scale designing, anything you can take. What is that logic? Concentrate guys. In this, I'm going to show how do we calibrate the device. That's what the point. Calibration means one type of designing only. How? Means this is 0, this is 0, this is 100, and this is 200. Okay. and this is 199, and this is 150. This is 50. This is one only. This is the wire. Kindly look at me. This is a slide wire. This is a paper, for example. On the paper, some length scale will be there. Only length scale. Okay. After that, what do we know? Kindly concentrate here. We need to calibrate the device. All I told you, the secondary instruments are designed. The secondary instruments are constructed or manufactured with the help of primary standards. I told you in the time of starting days. What is it? Standards we are having, we have seen. So therefore, in those standards, what I told you, secondary instruments are designed with primary standards or primary instruments, we can say. So therefore, what is it? Testing point of view. Be clear, guys. Testing point of view, I'm taking testing means calibration, etc. So we can say, so therefore, first step is calibration. First step is calibration. Sir, for calibration point of view, for designing the device point of view, what we require? Primary standards we require. So therefore, I'm taking, what is it? Standard cell. I'm taking standard cell. Right. Before that, okay, I would like to ask you one question. If this experiment was there in your laboratory when you're in the BTech or in the second any year, right? If this experiment was there, have you remembered that experiment means what? The size of this device is very large. This instrument is always kept on the table as it is. But other devices, PMMC, MI, EMMC, what do? We ask the lab assistants and they will give those devices from the Almara, etc. But this potentiometer is always on the table, generally at the corner table of the current table in the laboratory. Means this device is generally not portable, somewhat bigger size. At least this much size will be there, or 1 meter, 2 meter, like that will be there. I'm taking example purpose 2 meters. That's what the first point you have to observe. Okay, that's why potentiometer construction itself is bigger size basically. Why? Means to get one advantage, we have designed like this. The concept is like this. Right. Okay. Those who have conducted the experiment, they know that. Other people take it for granted. No need to worry. So after that, standard cell. What is the value of the standard cell? One of the voltages. You can take 1.5, you can take 1.3, anything. I'm taking 1.018 volt. This is standard cell available in the practical world. And here, galvanometer is being connected like this. So what is the galvanometer purpose? I told you, to sense the current in both directions. To sense the current in both directions. See here. Okay, right. Suppose, concentrate, guys. Now I'm getting the now I'm taking the calibration process. How do we calibrate and all? I'm taking now. So kindly concentrate. Right now, the point here is, sir, what you have to do now? You have to keep this pointer at this position. You have to keep this pointer at this position. Okay. Observe that galvanometer 0 or not. Observe that galvanometer 0 or not. That's what actual procedure. But in this, what I'm doing now, that calibration I'm doing, everyone concentrate here. Sir, I'm connecting this. At which point? 101.86 centimeters. Sir, why? You may be asking why. Means I want to calibrate whether the instrument is working properly, or otherwise I want to design the scale of this device. For that purpose, what I'm doing is simple logic I'm taking. You can keep anywhere, but I'm keeping here at one of the places. At one of the places, you can keep anywhere. But why am I keeping here? Means, see the number. See the number here. 101.8, 1018, 1018. Some numbers are matching. No, it is easy to understand. It is easy to understand. That's why I'm taking this number. Okay, I'm keeping at this point. Now what you have to do now? You have to vary this rheostat. Concentrate, guys. You have to vary this rheostat until the ammeter shows 0. You have to vary this rheostat until the ammeter shows 0. Sorry. See, you have to vary this rheostat. You have to vary this rheostat until the galvanometer shows 0, not ammeter, until the galvanometer shows 0. What do you mean by that? Everyone kindly keenly observe. If you understand this 2 minutes topic, everything will be very simple. Next topic, very, very simple. Kindly concentrate. Right? galvanometer. But the rheostat must be varied until the galvanometer shows 0. Okay, right? Once it is showing 0, stop varying this. Stop varying this means suppose it may be varied and varied up to this point, something is there. For example, something. Okay, now stop varying that. Sir, galvanometer current is 0. If this is 0, what does it mean? Kindly concentrate. If you take this portion, is it like earlier circuit diagram or not? Yes. Why? This is standard cell known. Galvanometer, and from A to this point I'm taking as some C point. A to C, we don't know the voltage. That is what we here. Unknown EMF in this. Okay, so that's why concentrate here. Right, concentrate everyone. So therefore, if this is showing the 0 means, what does it mean? Concentrate here. Ig is equal to 0 if where we have varied the rheostat until Ig is 0. If Ig is equal to 0, then that is called as voltage across AC is equal to voltage across standard cell is equal to 1.08 volt. Why? This voltage is equal to this voltage, then only galvanometer shows 0 definitely. That is what the first step you have to do in this corresponding method. Standardization, calibration, any name you can use, no problem. Any name you can use. Right? Yes. Very good, Vashishta. That only. Okay. After this, sir. Okay, we are not wearing this, sir. This must be placed at the time, at the place only. Leave it. Okay. After that, sir. Voltage across AC is 1.018 and standard cell is this one that we're writing. Now, sir, what is the resistance of this one? What is the resistance of this one? All I told you, 1 ohm, 1 centimeter. Therefore, what is it here? RAC is equal to 101.8 centimeter. 101.8 centimeter. What is that? Here, 101.8 centimeter. Sorry, 101.8 centimeter means 101.8 ohms. 101.8 ohms. Okay, why? 1 ohm, 1 centimeter, 101.8. Sir, voltage across AC is known. Resistance of AC also known. So why can't we get current here? So simply I am taking this current I. So can I write I is equal to VAC by RAC. What is VAC? 1.018 volt by RAC 101.8 ohm. Current will be how much here? 10 milliamperes. So I am conducting the experiment. I am doing the entire process with the 10 milliampere current in the circuit. So why only tell me that your wish? You can take some other place, anyone, but easy understanding purpose I'm taking like this. Okay, but sir, actually current is which current? Current through slide wire. But actually this is the current, sir. But you have written this is the current. How? People are getting confused. Concentrate here. It is coming over here. At this point, is it getting divided into two parts or only through this slide wire means only through this slide wire because our Ig already showed 0. If it is showing 0, do we have any current path through this? No. That's why entire current will be flowing through this only. That's why current through the slide wire is this one. Okay. Now with this entire thing, sir, under this entire condition in my experiment, what is the current we are maintaining means 10 milliamp. Repeatedly saying here, sir, why not 20? Why not? It is your wish. One of the values I'm taking for explanation purpose. You can take every value, all values you can change, but one of the values I'm explaining here. Okay, after that, sir, by doing this, I'm saying that, sir, experiment, nothing but the instrument is standardized. I'm saying, sir, what did we do? How the standardized means? Everyone concentrate. Again, this point also very important. So after 10 milliampere current, if you are maintaining the same 10 milliamp of current in this, very simple, sir, 10 milliamperes of current is flowing. Sir, already we know that resistance of the element. Sir, current is known, resistance is known. Can't we measure voltage across it? Can't we calculate voltage across this? Yes. Can't we calculate voltage across this? Yes. That's why what we can say, once we do all these things, we can say that okay, calibration is done. How? Length is known, length to resistance is known, current flowing is also known. After all, I into R only over. That is what called as calibrating the device. Means here 100 ohm, for example, concentrate here. Across this 100 ohm, how much voltage will be dropped? Across this 100 ohms, sir, 100 centimeter length, how much voltage is dropped? It's very simple, sir. 0 to 100 centimeter. 100 centimeter means 100 ohms. What is the current flowing? 10 milli. 10 milli into 100 ohm automatically. What is it here? 1000 milli. Means simply 1 volt over. This is what called as scale calibration. One scale to other scale calibration. Which scale? Length scale to resistance scale. Length scale to resistance scale to what is that? Voltage scale. But actually, 1 volt need not to be indicated. We know the mathematics. No. Yes, we can write it. That is what called as calibrating the device. Clear? Okay, sir. I want to calculate across 150. What is that? 150 centimeter, 150 ohm into 10 milli. Answer is 1.5 milli. That's it. Sir, in this entire thing, with my assumption, with my length and with my coil and assumptions, etc., how much maximum voltage we can measure means 2 volts. If you are changing this, it may be coming as 3 volt, 4 volt, 5 volt, also no problem. Clear? This is what? Calibration. Okay. After the calibration is done, no? Yes. Remove this entire thing. Remove this entire thing. Practically, we remove this, but in the classroom, I'm showing like this because if I remove this entire thing, people may be getting doubt like, sir, where did we calibrate? Confusion, no. That's I'm keeping as it is. Okay. Next one. Sir, I'm taking the second step here only, but I'm showing like this. What is second step is measurement step, because already instrument is calibrated, instrument is standardized, instrument is designed, we can say. Now we need to say that unknown EMF. Yes, this is unknown EMF. So unknown EMF, you're connecting in the circuit means automatically you are measuring that value. That is what called as measurement procedure. Right? Okay, measurement procedure. Now I'm connecting galvanometer and I'm placing here. Now what is our duty? We need to measure. We need to measure which value? Unknown EMF must be measured. We need to measure unknown EMF. Let's see. Thank you. See here, you need to measure these values clearly. So what is that measurement and all? Kindly concentrate here. Right, sir. Here, how do we measure? Very, very important here. This is already removed. Can you forget about it? Because first step physically we disconnected. But in the figure, I need to show. Sir, simply place here. Place here. If you're placing here, see, people are asking, sir, why only to be any place? Simply, I'm starting from this place. Place here. Observe the galvanometer. Suppose, everyone, suppose galvanometer shows 0. What is my unknown EMF? First question. What is it? If the galvanometer shows 0, what is my first one? What is my first one? Means, what is it here? The galvanometer shows 0 by keeping at this point. By keeping at this point means if the galvanometer shows me automatically, okay, path is not there. Means this unknown EMF is appeared across AB. Means voltage AB is equal to unknown. Voltage AB is equal to unknown. What is it here? Correspondingly, galvanometer shows 0. Automatically, galvanometer shows 0 means unknown EMF equal to voltage across AB. Okay, I'm writing that. Idea purpose. Unknown is equal to voltage across AB. Voltage across AB. What is the voltage across AB now? Same thing. We did not vary this. We maintained the 10 milli as it is. All I told you, no, 10 milli as we have to maintain. And resistance is AB 200. So simply 10 milliampere into 200 ohm. What's the value? 2 volt over. That's what the point. Now tell me, from this entire circuit, are you able to get the 2 volts or not? Are you able to get the 2 volts or not? Yes, we are able to get the 2. But do you have any device in this entire thing says that it is moving from 0 to 2 and showing the 2? Not there. That is what is that? The potentiometer, voltage measuring device only, but with the help of null indicating device. Okay. Suppose people are saying that, sir, if it is not showing 0, what do we do, sir? No problem here. No problem. You need to keep this at this point, or this at this point, or this at this point, or this like that. You need to keep on wearing that. That's why I told you slide wire means it must be slided on the corresponding length. That too, why I have taken this lengthy wire? No, 200 centimeter means 2 meters wire. 1 centimeter scale is there. 1 scale also will be there here. 1, 2, 3, 4, 10 scale will be there. That's why you can move this entire pointer by 1 next 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 like that. Keep on changing this. Keep on changing this. So what is that happening here? While we are keep on changing that, we need to observe the galvanometer. Once it is showing 0, stop it. For example, I'm keeping it 180. For example, I'm giving different questions I'm giving. By keeping it 180, if the galvanometer shows 0, if the galvanometer shows 0, then what is my unknown voltage? Very simple. Very, very simple. What is that? Unknown equal to VAB. This is the first question. This is the second question. Separate unknown. VAB equal to 10 milli is already maintained here. Everyone should follow 10 milli as is, because that is the maintained value that is to be maintained in the circuit into 180 centimeter means 180 ohm. So automatically 1.8 volt. That's it. 1.8 volt. Clear? Yeah, people give the correct answer. Yeah, actually, this is the main problem. Yeah, this is the main problem. When student is asking a practical question, so can we replace the galvanometer with old? Actually, we should not do. But sometimes we are doing. But if we do, if we replace the galvanometer with voltmeter, what will be the problem? I will explain clearly in the bridges topic also. I will tell you, no need to worry. But galvanometer means galvanometer only to be used. Voltmeter we should not use, but sometimes in laboratory we will do. That is okay. No comments on that. Okay. Next. Yes, we need to maintain the current, that is called as calibration. Yes. Nice. Right. Concentrate, guys. Concentrate. Sir, suppose I'm keep on taking that. I'm keep on taking this different notations. Different notations. Here, concentrate here. Suppose if I'm keeping here, you can find out. You're keeping here like that. You take the different unknown values and keep on sliding the pointer on the slide wire. Observe the galvanometer value as 0. Once it is showing 0, stop it. That length we know where it is coming, and length to resistance we know, automatically yes, go for this. Clear? And if one student is asking that, sir, explain the role of rheostat, I explain the role of rheostat. Kindly go back and watch the recorded video. I told you what is the role of rheostat. Already I told you that is what my first topic. That is what my first topic. This is the main problem. If you don't listen, this is the main problem. And here already I told you here, sir, positive to positive, negative to negative only we have to connect. Why I told you should understand as electrical engineer, Gagan. You should understand as electrical engineer. Sir, why? If I reverse this, do we have any chance of 0 in this? Come on, guys. Do we have any chance of 0 in this? No. This is 10 volt, this is 1000 volt, this is 100 volt, this is any one volt. There is no choice of 0 in the galvanometer. Why? This voltage and this voltage both will be coming in aiding. That's why the minimum thought is okay, opposite should be there. If these two are not opposite, our what is it? potentiometer operation will not be working out. Why? The potentiometer operation itself is null type, null indication. So therefore, both the voltage sources should be connected with the same polarity, should be connected with the same polarity. Clear? Right. See, if the galvanometer get damaged, bring the galvanometer. Bring the galvanometer. Okay. Right. That's why I told you clearly. This is the correspondingly null type. This is the correspondingly null type device, means null type. See, why didn't you get a doubt like, so DC machine do the experiment? Sir, my DC machine got damaged. What I have to do? Gagan, tell me. You're in the laboratory of machines laboratory. DC machine, you have to do the experiment. Already DC machine got damaged. Then what you have to do? Right? Right. So therefore, kindly concentrate step by step. What is that? I'm repeating the entire thing now. I'm repeating the entire thing. Sir, length something we have taken. Length something we have taken. And RAB also something we have taken for understanding purpose. 1-to-1 ratio I have taken. Everyone repeating the total thing, concentrate. Sir, first one, I have taken one standard cell, any one standard cell. In order to have the easy idea, I have taken same number base. I am keeping this at this point. And I'm varying this, I'm repeating the point, concentrate. I'm varying the rheostat until the galvanometer shows 0. Once the galvanometer shows 0, what does it mean? What does it mean? This standard cell voltage, this AC voltage, both are same. That's why standard cell voltage VAC same, 1.01. Based on this, I have calculated REAC, but I told this point also. So current is coming here. Will it be divided into two parts? No. Why? Galvanometer already shows 0. Already shown 0. Doing a current path, galvanometer is 0 means current path is 0. Therefore, there is no question of current coming over here. Through this only current will be going. Through this only current will be flowing. Okay, now as the current is flowing like this, we can find out I equal to VAC by REAC is equal to 1.018 volt by this. So and so current has come. So why only 10 minutes? With my values, I am maintaining 10 milli. After going home, kindly take the different values, maintain the different current, proceed same thing, nothing wrong. But in the class only, I will solve all varieties of questions. But for understanding purpose, easy number I'm taking. Suppose if I would have taken 400 here, what is it? 1:2. You need to multiply with the 2. Confusion. That's why I'm taking 1:1 notation. One thing. After calibration, right? You remove this. You remove this. Okay. Next, unknown EMF is being taken. First unknown EMF. X is my unknown. X is my unknown. And connected here, or here, or here, or here, like that. Keep on sliding the entire galvanometer. Observe the value of galvanometer as 0. Until the galvanometer shows 0, it has to be varied continuously. If the galvanometer shows 0 at any place, simply measure this length. Of course, already length scale is there. According to that length, resistance is known. And that resistance into already 10 milliamperes, that is not disturbed. No, simply 10 into so and so, 10 into so and so, 10 into so and so. We have to take it. That's what the corresponding total value. And be clear. People are asking that, sir, if the galvanometer is showing 0.5 or 0.6 or 2 or 3, our matter is not at all with respect to galvanometer non-zero. Our topic is galvanometers. That's why the moment you're connecting here, galvanometer shows some value. For example, what does it mean? This AB voltage, this unknown EMF, both are not same. If both are not same, current will be flowing. That way, it will not show 0. But our topic is not to write that unknown value. Our topic is not to write that unknown value. Our topic is, our main criteria itself is, we need to slide over the entire slide wire until the galvanometer shows 0. Until the galvanometer shows 0. That's why if the galvanometer is showing something else, we don't want. Until the galvanometer shows 0, we need to keep on varying that. But people are asking that. People are asking, sir, This is the irrelevant question, but generally people are not you people. Generally people are asking. No one has asked from your batch, but see here, I kept here through the entire surface. I have moved this slide where still it is not showing zero. What does it mean? What does it mean? This unknown EMF may be more than this AB value. That's why, come on here. This voltmeter gives how much value I told you? 0 to 2. Means unknown value should be between 0 and 2 only. Then only we connected. Suppose other potentiometer designed for 0 to 5. There you keep unknown values of 0 to 5. You're missing small thing. According to the scale capacity only, we go for unknown EMF. That's it. That's what the complete construction and complete operation of entire potentiometer. Clear? Right? Now, see, you can take anything. You can take any standard cell value. You can take any standard cell value. We are making the galvanometer equal to 0. So therefore, no problem for this entire thing. Now, finally, before concluding this, sir, I would like to define the resolution in this. Resolution. Be clear, guys. Resolution. What is the resolution formula? Full scale value by number of divisions. Okay, sir, what is the full scale value? Already we have taken 2 volt. Why? My current is how much here? 10 milliamperes in the circuit. Resistance is 200 ohm. Already gave you 200 ohm, 10 milli. 2 is the capacity. So therefore 2 volt by, be clear, how many number of divisions are there? Means I am taking 200 centimeter. So why only centimeter? Why not mm? Yes, 2 volt by 2000 mm. Okay, so 2 by 200, 0.01 volt per centimeter, 0.001 volt per mm. Both are correct only. Now the biggest question with the people is, sir, why can't we use PMMC? Why are you going for, come on here, already we know the PMMC. We are having the measurement with the help of other approach also. That's why we are taking this one thing. Second thing, sir, 0 to 2 volt potentiometer is there. 0 to 2 volt PMMC is there, which is having good resolution, which is having high sensitivity, or which is having high accuracy. In order to understand that, I'm taking the total discussion. Now, kindly concentrate. Without explanation of this, I will not go to the next topic. No need to ask about any doubt which is not happened so far. I will explain everything. Sir, generally, I told you PMMC instrument is a portable device or non-portable device. PMMC instrument means what is it? Electrical instrument only. What is it here? Carrying from one place, means from the almirah to you are bringing, you are carrying, and into the or near to the experimental setup and all. Experimental setup and all. So therefore, the point here is, concentrate here, sir. The PMMC instrument is always this much of size. I told you electrical instruments are generally this much of size, but potentiometer is also electrical only. Don't say mechanical kindly. It is electrical only. It is electrical only. But the potentiometer purpose itself is to design a device more than this type of resolution. That's why the potentiometer is generally large in size. That's why I've taken 2 meter approximately, but it may not be 2 meter practically, 1 meter. That's why I told you the entire table will be occupied by a single potentiometer circuit. Very lengthy with this much of size will be there. That's why whatever the construction you take, potentiometer construction is, potentiometer size is generally more than the PMMC. That is what the practical scenario. One thing, sir, as the PMMC is a portable device, small device, this much of size device, how many divisions you can make? How many divisions you can make on the scale? Means maximum to maximum 100 divisions we can make. That's why in my entire discussion, mostly I explained with 100 divisions only. Sir, in this small device, people are asking, why can't we make more? If you want to make, you can make more. But what happened, in this much of small size, if I want to make 2000 divisions, all the divisions are touching with each other. Because in the small size, can we make 1,000 divisions, 2,000 divisions with clarity space here? No, that's why generally PMMC 100 divisions we say generally. But in the potentiometer, based on its size, 1 meter size, 1.5 meter size, or 2 meter size. In my example, 2 meter size. 2 meter means 200 centimeter. 200 centimeter means 2000 mm. Mm divisions are spaciously there. Why? This is length-based structure, but this is not the length-based scale. So that's why in this 2000 mm are there. Here 0 to 2 volt only. Here also 0 to 2 volt only. I'm comparing. Sir, what is the resolution? 2 by 100. What is it? 0.02. But here 2 by 2000. What is it here? 0.001. But people are asking finally, sir, if I take 100 mm device only, actually 100 mm means 10 centimeter. That is not the potentiometer structure at all. I'm keep on saying that. I'm repeatedly saying potentiometer itself indicates comparatively larger size. But sir, are we getting the drawback with larger size? Yes, but you are getting the advantage. That is the reason why potentiometer basically itself is larger in size. So that's why don't take same size of PMMC. If same size of PMMC, potentiometer is of same size with PMMC, no need to study this potentiometer separately. That's why in order to overcome these drawbacks also, we are going for potentiometer. That's why potentiometer has better resolution even compared to PMMC. Even compared to PMMC. Kindly Govindo, you should not say resolution is more. No, resolution is good, you should say, because this is more correct only, but actual apt statement is good, we have to say, or better resolution, you have to say. This is better actually. Clear? Any more confusion? Right? So that's why for my designed instrument only, I'm giving all these. For my designed instrument only, I'm giving. Clear? People may be asking, sir, if I change this standard cell, if I change this current, that's why I told you, for my designed values only, I'm giving the result. If you want to change the slide wire, if you want to keep it some other place, if you want to maintain some other current, definitely different. Kindly let me explain one example. After that, go home. After the session in the home, take different values, take different pages of notes, nothing to worry. No need to worry. That's why my conclusions are with my examples only. Clear, guys? So this is the total discussion regarding which one here? Basic slide wire potentiometer. But no doubt, yes, obviously the disadvantage is which one here? Definitely the disadvantage is which one here? The size is large. Definitely size is large. Drawback, but with that only one technical advantage is there. That's why I'm giving the conclusion now. Right. Concentrate here. So the point here is I'm giving two applications here. Application 1, application 2. Application 1, application 2. In my first application, size is the matter. I don't want to go for large size. Go for PMMC. In the second case, whatever may be the size, I don't bother. I want to have best resolution. Go for pot. That is what the actual discussion. That is what the actual thing. Clear now? See, if I compare, concentrate. Right? If I compare, suppose Luna, everyone, TVS Excel and Royal Enfield, I'm comparing. Let me compare first. What I'm giving, Royal Enfield pickup is very good. Sound is very, firing is very good. Immediately don't say, so TVS Excel mileage is, come on here. Every structure has their own advantages and drawbacks. That's why resolution is better than the PMMC, but obviously size is large. whatever you prefer in your application, you can prefer that. No need to worry. No need to worry. Of course, caste wise also PMMC is good. Caste wise also PMMC is good. That's why according to the requirement, you need to go for it. That's what the point. But what is it? Size is obviously large only. Size is obviously large only. But with this large size only, we are getting the advantage. Okay. Now immediately, next topic is DC Crompton's potentiometer. DC Crompton's potentiometer. Concentrate here. He has given one theory. This is not our own theory here. Crompton's. He has given one theory. According to that only, we need to proceed because this is his theory, not my theory or not your theory. Based on his name, what he proposed, some conditions based on that analysis is being taken. What is that? I'll tell you. Concentrate. Right, sir. DC Crompton's potentiometer. DC Crompton's potentiometer. The point is, with this structure, two advantages are there. Two advantages. One is means he is proposing the system for two advantages. One is size is being reduced. Means don't think like the size is reduced from this one to this one. No, right? From this one to this one size. Still it is bigger than PMMC. Only take it for granted. That's why potentiometer size itself is bigger than PMMC compulsory. But in that very large size we have taken so far, with the same notations and all, we are trying to reduce the corresponding size. Therefore, what we can say, size is reduced from the slide wire potentiometer. But don't think that size is reduced means it is becoming PMMC size. Never. It will be a little bit bigger than the PMMC only. Okay. Now come to this. What is that, sir? Here, how can we say that? Everyone concentrate here. When can we say that the slide wire potentiometer size is reduced? Means people are saying that, sir, take the length of 100 centimeter in the second case. Come on, by taking that, can we say size? I am able to reduce the size? No. You have to take same 200 centimeter length only, but still we have to design a circuit says that size got reduced. How is it possible? That is given in the corresponding Crompton's potentiometer. Crompton's potentiometer. What is it? Crompton's potentiometer. Let me take now. What he proposed, here, slide wire length. Slide wire length is 200 centimeter only. Means same length what I have taken in my earlier explanation. Same thing I'm taking here, but I'm going to prove that. I'm going to show that, right? What is it? Size is less. How? I'll tell you. Size is less. How? I'll tell you. But people are saying that, sir, length is 200. By reducing the divisions, size is less. Are you able to get reduced size with that reducing the divisions? No, yeah. Length itself is 200 centimeter. Length itself is 200. Means wire length of 200 centimeter only. But I'm not taking a straight line like this. I'm taking a circular wire like this. Concentrate. This is straight wire. From this tip to this tip, straight wire. Simply I'm keeping circular wire. Who is keeping? I'm not keeping. He has kept and he proposed the theory. That is what. Concentrate here. This is voltage source, rheostat, same thing. And this is known EMF, ammeter, everything is same. Now, between these two, right? What is that? Slide wire is being connected. But I told you two advantages. What is that? One advantage is, sir, this slide wire is made a circular structure like this. Obviously, instead of keeping lengthy straight wire, simply we can keep this like this circular wire. Okay, automatically we can say, sir, size got reduced. One thing, right? So people are giving different shapes. I am taking Crompton structure only, not my own potentiometer, not your own potentiometer. I am taking Crompton potentiometer. Let me take that. Try to understand. If you keep on, I'm keep on saying that if you keep on typing, definitely you don't understand. Your money waste, time waste, health is also waste. That's why leave the session happy actually. If I keep on typing along with my explanation, your parents' money will be wasted. and your time will be wasted. Otherwise, you can watch your movie or etc. And by sitting in front of laptop or mobile phone, health will be wasted. Why are you wasting? Anyway, you're not listening. No, yeah. Few people. Anyway, you're not listening. Why to waste all this? Simply leave the session. That's better actually. At least you can save your health also. At least you can save your health. Clear? Right. Now, this is the slide wire. This is the slide wire. What is its length? 200 centimeter means 1, 2, 3 like this. 200 mm scale divisions will be given over here. 200 mm scale divisions. Okay, but he has given one more thing. What is it? 1 second. Sir, he has proposed, I told you, his proposal, the resistance of the slide wire. Now he is not taking 200 centimeter. He is taking resistance of the slide wire is just 10 ohms only. Why means to get one more advantage, to get some other advantage, he is proposed. Sir, why only 10? He proposed 10. Generally, we take 10. Yes, sir. But here you can change this. That is your wish. But this is slide wire 10 only. Based on this only, Crompton theory is being taken. Crompton theory is being taken. Okay, right. Now, sir, our slide wire is 10 ohms. Okay, right, sir. Between these two, one more resistance box we say. Resistance box will be connected here. This resistance box has different number of steps, some 10 number of steps like this. In my explanation, I'm taking 10 number of steps. You can take 10, 15, 20, 30, 40 as you wish, right? I'm taking R dial box we say. Otherwise, R box we can say. How much I'm taking? That is only example. Here I'm taking 10 steps into 10 ohms each. Totally, I'm taking 100 ohm. Totally, I'm taking 100 ohm. Clear? Be clear. Sir, this is A and this is B. Okay, sir. What is the total resistance now? RAB is. What is it? R box is 100. R slide is 10. 110 ohm I'm taking for explanation. This is standard point. But this one is as wish, no problem. But only idea purpose I'm taking. Okay, one value. Sir, from A to B, from A to B, I'm repeating, from A to B, how much resistance is there? 110 ohms resistance is there. But be clear, already we know, already I told you, know, what is that? 10 milliamperes is to be maintained. For my explanation, I'm taking 10 milli. You can take any number, but explanation purpose, I need to take one number. That's why I maintained as, how much here? 10 milli only. How? Means same concept of calibration. But don't worry, I will explain again. How to have the calibration, I will explain again. Yes, you can understand. But as of now, what is the calibration is done? Assume that, okay, 10 milliamperes is flowing. Okay, sir, 10 milliamperes is flowing here to here, 100, here to here, 10. What is the total? 100 and plus 10. So therefore, sir, what is the voltage across AB? What is the voltage across AB? What is that? 10 milliampere into 110 ohm. So therefore, how much value? 1.1 volt. Sir, earlier device was measuring up to 2, but by having this modification, it is measuring after all 1.1 only. It is a drawback. No worries, no worries. Here, in the place of dial box, what is that? I'm taking 200 ohms, for example. 20 steps or 20 ohm, like that, 200 for example. What will be there here? 210. What will be there here? 2.1 volt. That's why if we want to have different values of voltages, we can have different values of resistance boxes according to our requirement. According to our requirement. That's why this is for which purpose, we can say indirectly extending the range. Can we say or not? Extending the range. If this is not there, concentrate. If this is not there, what is it? Simply coming over here. What is it? 10 milli at any cost we maintain. 10 milli into 10. 10 milli into 10. What is that? V slide. Concentrate guys. V slide. What is that? 10 milliampere into 10 ohm. What's the value? 0.1 volt only. Means if you are using only slideware with his standard point, we are able to measure up to 0.1 only. Come on here, we need to have extra value such that what I told you here, we can keep resistance box like this. Yes or no? If you are keeping the resistance box like this, automatically we are able to measure larger values directly. But one doubt will be there. I'm going to clarify that doubt. Concentrate here. Resistance box is being taken like this. Okay, right here, different tappings. I'm taking 10 steps, etc. For example, 10 steps value I'm taking. Sir, here, concentrate, guys, concentrate. Sir, slide wire is placed. What is that? This is the value. After that, what did I do? Here, 100 ohms I kept. Here, 10 ohms I kept. But people are thinking, this is general doubt. I'm clarifying this doubt. Concentrate. No one should ask the same doubt after the topic. Concentrate. Sir, 100 ohms you kept means already 10 was there. This was the value. We have added the 100 ohms. Sir, 100 ohms is added means definitely current will be reduced. But by varying this rheostat, we are going to maintain same 10 milli. That's why in my entire explanation, my instrument current is 10 milli. That's why I am maintaining 10 milli. How do we maintain? Means rheostat is there. No, keep on varying this rheostat 10 milli. That's why yes, 10 milli here, 10 milli here I'm taking. Suppose, sir, I'm keeping 500 ohm, no problem. Everyone, 500 ohms, no problem. So resistance is increased, current will be decreased. Yes, but rheostat is there. Rheostat is there. By keep on varying this rheostat, always maintain the 10 milli only in our experiment. Suppose you are taking 20 as reference, 20 milli, 30 as reference, 30 milli, that your wish. But I am maintaining 10 milli. That's why kindly no one should have this doubt. No one should have this confusion such that no one should have this confusion such that sir, resistance is added, current should be decreased. No, current will be maintained every time. But based on this statement, one more doubt you are getting, sir, current will be maintained means current is variable. No, yeah. In my application, I kept 100 ohm here, right? I maintain 10 milli. I am doing the experiment. My part is over. Suppose you are taking your application maybe 200. Then what you have to do? In your experiment, vary this, maintain 10 milli. That's why don't say this current is variable. No, in a given experiment, for a given condition, the 10 milli must be maintained as constant. 10 milli must be maintained as constant. So no, that is the reason why what we can say now. If I say 100 ohms means my experiment calibration is done. Well, calibration is done, but the rheostat is varied and 10 milliampere is maintained. My experiment is done. Suppose my experiment is over. I'm giving this device to you, right? You are taking your application is different. You are taking some 300, etc. Now you have to calibrate first. How? Vary the rheostat and maintain this, calibrate. After the calibration, proceed for all. So that's why don't get the question like, sir, after calibration, rheostat is variable. No, yeah, you are varying the rheostat means itself is the calibration. That's why if I say 100, 200, 300, that is not in the single experiment. 100, my application. I calibrated for 10, done. Second, you are taking 200, you have to calibrate for 10 milliamperes. Proceed. Suppose your friend is there, 300. So therefore, each and every case, we need to calibrate the device by varying the rheostat. But don't think like rheostat is varied after the calibration. No, after the calibration, we don't. Clear? Okay, right. Now, here, sir, I told you 100 first. Suppose your application may be 20 ohm. Accordingly, rheostat must be varied. Rheostat at maximum or minimum or medium. We don't want. What is it? My application 100 is it? I want to get calibration. Yes, maintain the 10 milli by varying this rheostat. Okay, my experiment is over. I am taking out my device. You are connecting 20 ohm device. According to your device, you need to calibrate the device. That is what always during the calibration, correspondingly rheostat will be varied. In my explanation, 10 milliampere I am taking with the calibration, not after the calibration. Prakash, you're typing, that's why you're not getting. You're typing. Listen carefully. In my application, I am calibrating for 10 by keeping 100 ohms. I'm repeating almost fourth, fifth time I'm repeating. In your application, this resistance box is 20 ohm. By keeping that, again, calibrate it for 10 milli. In your friend's application, this is 500. By keeping that, your friend will be calibrating by varying this for 10 milli. That's why after the calibration, we are not varying. That is before the calibration only. But I'm as a faculty, I should say, not only 100, you can change it means not in the single experiment of talking. Every see, if you are keeping this 100, calibration is to be taken. Again, you are keeping this 200. Again, you are varying means again you are taking the new question, new topic, new device. So new calibration is to be given. So that's why one of the things I have taken. So varieties of explanation I gave you in a different way. Right now the question is, sir, this one complete discussion you have taken. But now, sir, what is the resolution? Very, very, very important. I can give that statement 100% guarantee confusion will be there. I'm requesting at least for this, have the patience, have the concentration. What is that? Resolution. Sir, full scale value by number of divisions. 100% doubt will be there. Kindly keenly observe that. Keenly observe that. Full scale. What is that? Full scale value. Now tell me, full scale value means 0.1 you have to take or 1.1 you have to take. That's what the question. Be clear. 1.1 is the voltage across this in my example. Is no? 1.1 is the voltage from here to here. Sir, from here to here, do you have the scale divisions? No, only for this scale divisions are there. This is simply a rheostat, simply a resistance box, simply a resistor we can say. But people are thinking, sir, one division, two division, these are not the division. Those are the varying steps. Those are the varying steps. So that's why 1.1 is not the full scale value, which is the full scale value. Means scale, I'm stressing the word scale is there only for slide wire, not for potentiometer. That's why the full scale value means which one here? We have to take only 0.1 but not 1.1. But sir, what is 1.1 now? 1.1 is extended range. All I told you, no, if this is not there, if this is not there, how much value? 0.1. If this is there, up to 1.1. If something else is there, 2.5, 3.5, 4.5, all those are nothing but our PMMC voltmeter, MI voltmeter. We have extended the range. No, yes, it is also same as range can be extended. But full scale, I'm repeatedly saying full scale will be same. Why? Divisions are same. Current is always same. Automatically, full scale value will be same. That's why what you write here, full scale value is 0.1 volt only. Number of divisions are how many are? 2000 mm. 2000 mm. Or you can write 200 as you wish. No problem. One thing I'm taking, sir, 0.1 by 200. 0.0005 volt per centimeter. Each and every step I explained 3-4 times. Kindly concentrate. I'm repeating this point especially because 100 people out of 100, I'm guessing doubt will be there generally. If not happy, I'm very happy. But doubt is that don't get hesitated. Full scale, I'm stressing again, full scale. Scale means scale divisions are only for this, not for this. Still doubt is there. Okay, I'll be going back to the 4 or 5 days class. What is that? Here, PMMC instrument is there. 0 to 0.1 volt is this, for example. And I want to operate it for 0 to 1.1 volt. How do I operate? Means by adding the rheostat RSC. All I told this, sir, after adding this RSC, concentrate here, after adding this RSC, right? Do you have any change in this full scale value? No. That's why kindly visualize PMMC instrument scale is there. That's why I made dotted box over there. PMMC, I told you, scale is there. This element not changing its scale. All I told you, this RSC should not change the instrument scale, should not change the instrument full scale value, should not change the instrument resolution. This is only for extension. Same thing, sir. Scale is there. These two are similar. So this is extra resistance added for this similar. Okay, one more thing, sir. I have added rheostat of how much here? 100 ohm, for example, 10 milliampere. Full I'm maintaining up to how much? 1.1. This is my application. Suppose second application is giving that it must be increased up to 4.5. Up to 4.5, you need to add 440 ohm. Why? 440 ohm plus 10 ohm, 440 ohm plus 10 ohm, 450 ohm into 10 milli, 4.5 ohm. Now tell me, even though you are adding this resistance, for one application some X ohm, other application Y ohm, other application Z ohm, if you keep on changing that, automatically range is changed, range is getting increased, but full scale value is not changed. All I told you, full scale value is up to this only. Same thing is happening in our potentiometer also. That's why full scale value means automatically you have to take 0.1 volt only in my example. Okay. Still people may be having doubt. Okay, let me take. Sir, I will take 1.1. What will happen? Okay. Sir, where will be 1.1? From A to B. From A to B, 1.1 is there. Okay. Sir, number of divisions means you should write from A to B only. Why? You are taking from A to B in the numerator. Denominator also you have to take from A to B only. If you take A to B, can you write the number of divisions over here? You cannot. You cannot. That's why. Can you write like this? 200 centimeter means numerator is from A to B. Denominator is only from slide wire. Not at all. You have to take entire thing automatically. 0.1 slide wire, 200 slide wire, automatically 0.0005. 0005. What is that? Volt per centimeter. Now, sir, in the what is it? Slide wire potentiometer 0.01 volt per centimeter was there, but now 0.0005 volt per centimeter. Automatically, what we can say? Resolution is better than slide wire. So that's why in this advantages are what is that? Size is reduced. Of course, size is reduced from slide wire, but not up to PMM size. Only slide wire size. If you compare this size, it will be less. Second one is very, very important. Resolution is better. Resolution is better means better than slide wire potentiometer. Resolution is better than slide wire potentiometer. Clear? This is what the complete discussion. Resolution is 0.0001. People are giving. Come on, guys. 0.1 by 200. If you are unable to calculate this mathematically, use the calculator. You will get the same value. This is the total discussion regarding potentiometers construction, operation, and calibration and measurement also. But something is missing here. I give the overall concept. What is the size? What is the capacity resolution? Okay. But how do we calibrate? We should know. How do we maintain 10 milliampere? We should know or not? Yes, everyone. Those who are asking, so 10 milliampere, etc., etc., we are asking, no, kindly concentrate. How do we calibrate? Be clear. Why I'm taking calibration at the end of the topic means already we know calibration first, measurement later, same thing approach. But in this, I'm taking calibration at the end means calibration circuit is somewhat complex. How? Concentrate here. Two switches will be there. Two switch positions will be there. Okay. Now this will be brought here. How to calibrate? I'm giving that here. It has two switches like this. Nothing but double pole with the two side switches there. One side, concentrate guys. I'm taking one dash. Here, supply is given. Everyone concentrate here. This is standard cell. How much voltage? 1.018 volt. Automatically standard cell is there means calibration. That's why I gave you one dash as the calibration path. Everyone, it is also for many people doubt will be there if you don't concentrate. Kindly keenly observe this. What you have to do now, what we have done in the earlier case, I'm going, sir, standard cell. Where did we keep? Across 101.8 ohm we kept it. Across 101.8 ohm, so that 101.8, 1.018. Easy number is there, no? Yes, that's why I'm explaining at this point. 101.8. Here also same thing. Consider here also same thing. We should connect this standard cell towards with respect to 101.8 ohms. That's why be clear. It is connected over here. It is connected at this point. Concentrate here. From standard cell, kindly concentrate. From standard cell, current is flowing like this. Throughout the entire resistance flowing means how much resistance is covered? 100 ohms is covered. Plus this point, this must be kept at which value? 100 ohm plus 1.8, 101.8. So therefore, while doing the calibration, concentrate here. This will be kept at starting point like this. This will be kept at 1.8. This is 0, no? 1. What is that? 100 plus 1.8. So that 1.018, 101.8 number is matching. Now, vary the rheostat. Consider here, vary the rheostat until the galvanometer shows 0. Sir, where is the galvanometer? Here we can connect galvanometer until the galvanometer shows 0. Everyone again, sir, once the galvanometer shows 0, what we can say here? Sir, from standard cell voltage appeared between this point and between this point. Why? Galvanometer showing 0 means between this and this point, voltage will be equal to which value? Standard cell. Sir, across this, how much voltage will be there here? Same topic. 1.018 by the resistance, current will be 10 milli. In this way, we need to calibrate the device. Okay, for which one you have calibrated here? For which one you calibrated here? Here, for, one second. Right, for which one you calibrated here? Only for 100 ohms resistance we have taken here. We have calibrated for 10 milliampere. Okay, now be clear. I am not changing myself intentional. No, I am taking the second application. Means suppose I am keeping here 290 ohm, for example. I am not changing in single experiment. I am taking second experiment, means second application, 290. So what is this resistance? 290. What is this resistance here? 290 ohm. Yes or no? That's why while you are calibrating, again, what is that? Our topic is 1.018 means 101.8 is better. So therefore, how do we connect this value? This anyway 290 ohms. No, that's why what you have to do, while calibrating, you have to keep at this point, at any point, such that this resistance is 100. This resistance is 1.8. Easy point I'm giving. 100 plus 1.8, 101.8. Again, galvanometer 0. While varying this one, again, current will be 10 milli. This is second experiment, second construction, second device, second calibration. Okay, and one more doubt people are getting, sir, why do we take like this? Why can't we take 101.8 here only by keeping this resistance here? Okay, but here each step 10 ohms I gave you, some problem. That's why whatever you do here, simply you need to connect the standard cell across the 101.8 ohm, because my cell is 1.018 old. Therefore, both will be matching. No, yes, answer will be 10 milli into picture. That is what the corresponding point. Right, this is what calibration. Okay, sir, after doing this entire thing, sir, calibration is done. How much current is there? 10 milliampere current is there. Happy, leave it. Okay, now what you have to do? You have to remove this entire thing. You have to remove this entire thing like this. But I'm not removing to have the clarity. I'm showing that as it is. Now I'm changing to switch to. I'm changing to switch to position. Means I'm showing both. Actually, we remove this practically, but I'm showing like this. Sir, this is 2 dash. Here also one voltage, but which one it is? Unknown voltage. unknown. Everyone, I'm asking the GATE questions and ESC questions orally. Already asked these two questions. How? Here, at this point, how much? All these are questions only. Now, again, I'm asking, sir, unknown EMF will be below 0 to 1.1, below 1.2, because its capacity is 1.1 in my example. Okay, now concentrate. Sir, if my unknown EMF is connected, what is our duty? Here, rheostat already fixed. We are not changing because calibration is done. Okay, now I change this to here. Unknown EMF, we don't know. That's why what you have to do, kindly concentrate. You vary this here and there. You vary this here and there until the galvanometer shows 0. Everyone, keenly observe. You need to vary this and vary this until the galvanometer shows 0. Once the galvanometer shows 0, stop it. Assume that it is this entire resistance is 90, for example. This resistance is 2, for example. Sir, across how much resistance it is showing 0 means 90 plus 2, 92 ohm. 92 ohm into 10 milli. What is that? 0.92 volt. So voltage source value is 0.92. Means whatever we have done in the slide wire potentiometer, same thing we are doing here also. But there only one resistive wire. Here two resistive wires are there. First question. Second question I'm asking again. Concentrate. You keep on varying these two. You keep on varying these two. Suppose it is kept here. For example, right? This resistance is 100 covered. It is kept here. This resistance is totally 1.8 is covered. Means you are connecting at this end and at this end, means across 101.8 you are covering. Yes or no? Or sorry, this is 10. No, okay, I'm taking 10. Total 10. 110 means total 100 you are covering, total 10 you are covering, 110. So therefore 110 ohms into 10 milli, sir, 1.1 volt. Yes, maximum here to here, 1.1. In that way, by keep on changing by keep on varying the wiper contacts, by keep on changing the wiper contacts, but there only wiper contact, only the variable galvanometer, only one. But here two things are there, only that is a problem. Other than that, everything is same. That's why in this test you have to count, this test also you have to count. Thereby, we need to measure the unknown EMF. This is the complete discussion regarding entire concept of Crompton's potentiometer. I can say total concept of potentiometers. Clear, guys? Now, so whatever the doubts you asked earlier, all those doubts clarified here. That's why wait until I give you. That's what the complete discussion. Sir, are we varying I after calibration? No. If you are varying the rheostat means that is a new experiment calibration, because 100 I removed, 500 I'm keeping over. Again I'm removing 1000 I'm keeping. Means what is that? Each and every value you are placing means that is each and every step of calibration. That is each and every step of new concept, new device, new calibration, new corresponding setup. That is what the complete discussion. That's why here also check it here. While you're drawing in your notebook, after seeing, see positive connected to positive side. That is compulsory. Otherwise, no question of 0. Positive connected to positive side. There is, otherwise, there is no question of 0 at all. This is a total discussion regarding potentiometers. Clear? Now, if we solve the numerical questions, right, definitely you will be understanding. You will be understanding what is it. Let us take now. Right, all varieties of numerical questions. Let us take now. In the numerical questions, I am going to show with different values calibration. With the different values calibration, I am going to take. Clear? Right? Now, sir. First question. Very simple question I'm giving. Conceptual question. When a potentiometer is used for measurement of voltage of an unknown source, the power consumed in the circuit of unknown source under null condition. Concentrate, for easy purpose I'm taking here this one. Sir, it is connected over here. Null condition. What is the power consumed? Zero. Why? No current is flowing. So automatically answer will be which one here? Zero. Ideally zero. Very high? No. High? No. Small is also no. So obviously zero. Why? No current itself is flowing. Yes, ideally zero. Very good. Now, still whatever the doubt is there, all those will be clarified. Kindly concentrate. Kindly concentrate. Slide wire questions will be done and Crompton's potential questions also will be done. Kindly concentrate. No one should write while I'm explaining. No one should write. Kindly concentrate. I will explain. Kindly concentrate here. What is the given data? You must be able to understand the given data to draw the diagram. Sir, a wire potentiometer in a slide wire only. Length 11 meters and resistance of 1 ohm per meter. First of all, concentrate. Here to here. A, B. What is that? 11 meters. 1 ohm per meter means 11 ohm is there from here to here. Draw this first. After that, standard cell, I told you, 90% of the question, I can say 99% of the questions will be based on standard cell 1.018 only. That's why I've taken the standard theory. Okay, concentrate. No, don't try. I will explain this question. Next question, I will wait. You need to give the answer. Standard cell of 1.018 volt. Standard cell of 1.018 volt along with the galvanometer anyway. Where it is placed here, length of 10 meters 18 centimeter means 10.18 meters. So therefore this is placed at this point. What is this? 10.18 meter. He has only given, right, balances a standard cell voltage of 1.018 volt at a length of 10 meter 18 centimeter. What do you mean by that? It is balancing. Balancing means galvanometer is zero. Sir, what is it? I'm taking this as a C point. Be clear, guys. When the galvanometer is placed at 10.18 meters, the circuit is balanced. Terminology balanced means galvanometer shows zero. Okay. Once it is showing zero, automatically, what is the voltage across A and C? What is the voltage across A and C? Concentrate. Therefore, everyone observe here. Voltage across AC equal to voltage of standard cell is equal to 1.018 volt. Okay, the voltage is same voltage 1.018 volt. Okay, right. After that, this is what done. Next, what is given? If the voltage of the battery supplying a current through the potentiometer is 2 volt, definitely some current has to be passed, means some voltage should be there. What is this? This is 2 volt. This is supplying the current through the potentiometer. Okay, after that, sir, the value of the series resistance connected to the potentiometer means this is the series resistance he is asking, that is rheostat. Indirectly he is asking rheostat only, but according to his question I'm writing RESC. Clear? RESC is dash. Okay, very important, sir. VAC we got it. So what is RESC? 10.18 meter is there. He has given that 1 ohm equal to 1 meter. 10.18 meter means I can write happily 10.18 ohm. Therefore, RESC is equal to 10.18 ohm. So with respect to this, can't we calculate the current? Yes. I is equal to VAC by RAC. Same procedure, whatever I have taken, same thing will be there in the numerical. That's why I told you. If you understand step by step, thing will be easy. What is that? 1.018 volt. What is that? 10.18 ohm. So therefore, you will be getting 0.1 ampere. But he is not asking current. See, in my experiment, what is that current? 10 milli I maintain. He is maintaining 100 milli. That depends on his notation. That depends on. That's why for one value, I told you for different values there, that is there, this is there. We cannot answer randomly unless and until we take like this step by step. We cannot answer randomly. If that is there, this will be there. Not like that. That's why whatever the value I have taken, follow that first. Follow that first. Okay. Next. After that, finally, sir, current, this I'm writing as I. Sir, it is a simple mesh. It is a simple mesh. Voltage equal to current into total resistance. Sir, therefore, voltage equal to current into RSC plus R slide wire. What is that V? 2 volt. I 0.1. RSC unknown. R slide wire, how much? 11 ohms. So therefore, RSE is equal to RSE is equal to which value? 20 minus 11, 9 ohms. This is what the actual criteria. Okay, right. Now answer is 9 ohm. That's why people got headache actually. Why 10 milli? That is only explanation purpose I have taken. If you are keeping somewhere else, some other value, some other current will be there. For that current, you need to proceed. That's why for my current 10 milliampere, I have proceeded. That's not the point. Clear? Right. Next, one more question. Directly you can answer. In the potentiometer circuit shown in figure, the balancing condition is obtained. Balancing condition is obtained. What is the balancing condition? Galvanometer is showing 0. Sir, very simple point here. To confuse you, this resistance is given, galvanometer resistance also given. But under balancing condition, galvanometer shows 0 means no current flows through this. Automatically, drop will be 0, drop will be 0, no use. But only to confuse you, these two are given. That's why I'm slightly modifying. Very, very simple question. Under balancing condition, I'm redrawing the circuit. This is 200 ohm, this is 3.2 volt, right? After that, here this is one resistance and this is one more resistance. I'm separating. He has given no. This is 200, this is 2800. Okay, under balancing condition means directly across this he has connected. No, directly EX will be appeared. Very, very simple. Why? Galvanometer current is 0, no drop, no current is flowing. So directly this will be here, this will be here, appeared. So simply voltage division law, nothing more than that. But question is looking like complicated. But if you spend 30 seconds of time, thing will be done. Now tell me, therefore, EX is equal to 3.2 into 200 by totally 3200. You will be getting 200 millivolt. 200 millivolt. Sharanya, can you check it? It is not D, it is A. Got it? Right. One second. Same question, but I'm giving different image. It is not clear. Everyone, take this as the homework question. Take this as the homework question, but already I have done the same model. Concentrate. He is asking, what is it? Current and resistance of series rheostat. In the earlier question, we have done two values. What is it here? Here, in this earlier question, current we have calculated, resistance also, same thing, but only dimensions are changed. Only dimensions are changed. And in the question, see, in order to find out these two, Yes or no? Some data is given, some other data may be given excess to confuse you, to kill your time. Excess data may be given. Don't waste your time. Take this as a homework and give me the answer. I am giving the answer also. This is what the answer. Kindly get this. Clear? So this is a total thing related to today's session. Right. I'm stopping now. Let us have the doubt session now. People are ready for asking the doubts. Very good. But without listening, they are ready to ask the doubt. That is what the main problem. I explained 2 times, 3 times, 4 times. Still, people are asking the same thing. That is what I'm feeling very bad about myself, especially in this batch actually. Rohit Dasi, for which question you are asking, for which dimension you are asking, that kindly give me the total question, then I can answer. But comparatively today, few people only. Very good, very good. Because topic is very simple actually. Come on, I'm allowing you to unmute from your side.
Hello, sir.
Yeah.
Sir. Sir.
Hello, who is this?
Sir, Tulasi, sir.
Yeah, tell me.
Sir, in DC Crompton's potentiometer.
Yeah.
Sir, 0.1 is constant for any division we will take, sir, in resolution.
The 0.1 is constant. That's what I'm saying. Okay, very good. Yeah, this one.
Means I got it.
Got it?
That 0.1 is constant for any value we will take.
Definitely, because you are not changing this. See, other people also might have the same doubt, I hope. See, this you are not changing, this you are not changing. Yes or no? And
Yes,
this only you are changing. That's why full scale value always same, only this will be changing. Got it?
Okay. Yes, sir. Thank you.
Okay, very good. Yes, one more.
Sir?
Yeah.
Sir, galvanometer
Galvanometer?
Galvanometer చెప్పారు కదా సార్
Yeah, ida? Yeah.
Basics potential.
Idamma?
Basic slide, sir.
Basic slide, yeah.
Slide.
Yeah.
సార్ ఇందులో మీరు ఏమన్నారు గాల్వనోమీటర్ అనేది కనెక్ట్ చేస్తున్నారు కదా సార్, ఇది 10.100 దగ్గర కానీ అట్లా కనెక్ట్ చేస్తున్నారు కదా సార్. కనెక్ట్ చేస్తుంటేనే కదా సార్ అన్నోన్ వాల్యూ వస్తుంది, ఒకవేళ కనెక్ట్ చేయకపోతే జీరోనా సార్?
అమ్మా జాగ్రత్త చూడండి, మీరు ఏది కనెక్ట్ చేస్తున్నారు? గ్యాల్వనోమీటర్
మెజర్మెంట్ కి అన్నోన్ ది గాల్వనోమీటర్ 100 దగ్గర కనెక్ట్ చేస్తున్నప్పుడు అన్నోన్ వాల్యూ వస్తుంది అని చెప్తున్నారు కదా సార్.
దగ్గర అని చెప్పాను నేను, ఎక్కడైనా సరే అన్నా.
అది ఎక్కడైనా సరే, అదే మెజర్మెంట్ లో 100 దగ్గర కానీ 150 దగ్గర కానీ అక్కడ కనెక్ట్ చేస్తేనే అన్నోన్ వాల్యూ వస్తుందా?
మీరు మిస్ అవుతున్నారు మళ్ళీ. ఇది ఇలా కనెక్ట్ చేస్తూ పోతూ 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 ఎప్పటి వరకు వేరీ చేయాలి అంటే గ్యాల్వనోమీటర్ 0 చూపించేంత వరకు. గ్యాల్వనోమీటర్ 0 చూపిస్తేనే మనకి అన్నోన్ వాల్యూ వస్తుంది. అదే కదా మన ప్రాసెస్. మన ప్రాసెస్ ఏంటి? స్టార్టింగ్ ఇక్కడ చూడండి, గ్యాల్వనోమీటర్ 0 చూపిస్తేనే అన్నోన్ ఈఎంఎఫ్, నోన్ ఈఎంఎఫ్ అని వాల్యూ, ఏదో వాల్యూ ఫైండ్ అవుట్ చేస్తాం. ఇక్కడ ఏంటి, మనం ఇలా ఇక్కడ పెట్టాము, ఇక్కడ కనెక్ట్ చేసాము, గ్యాల్వనోమీటర్ 0 చూపించట్లేదు, అన్నోన్ వాల్యూ వస్తుందా? మనకి రాదు. అగైన్ ఇక్కడ పెట్టండి, 0 లేదనుకోండి, సపోజ్ అన్నోన్ వాల్యూ రాదు. సపోజ్ ఇక్కడ ప్లేస్ చేసినప్పుడు, ఇక్కడ ప్లేస్ చేసినప్పుడు గ్యాల్వనోమీటర్ 0 చూపిస్తేనే ఏంటి మనకి, అప్పుడు ఏమంటాం మనం, ఓకే ఈ ప్లేస్ లో, ఏ ప్లేస్ లో 150 అనుకోండి, ఈ 150 ప్లేస్ లో 0 చూపించింది అంటే 0 to 150 అనేది ఏ వోల్టేజ్ అయితే ఉందో ఆ వోల్టేజ్ ఇక్కడ ఉంది, అలా అప్పుడే మనకి అన్నోన్ వోల్టేజ్ వస్తుంది. ఇప్పుడు మీ డౌట్ అడగండి మళ్ళీ.
ఓకే సార్.
అంటే మీ ప్రాబ్లం అంటే జనరల్ గా మీరు
ఎప్పుడైనా కానీ అన్నోన్ వాల్యూ నోన్ వాల్యూ ఈక్వల్ గా ఉంటదా సార్? 0 గాల్వనోమీటర్ అనేది ఈక్వల్ అయితేనే నోన్ వాల్యూ అనేది అన్నోన్ వాల్యూ ని ఈక్వల్ అవుతుంది అని చెప్పాలి.
అట్లా చెప్పట్లేదు, జాగ్రత్త చూడండి, మీరు మిస్ అవుతున్నారు. ఇది చూడండి అమ్మా, ఇది 0. అదర్ పీపుల్ ఆల్సో మైట్ హావ్ సేమ్ డౌట్, కైండ్లీ కాన్సంట్రేట్. 0 to 200 centimeter is there, no? I am writing this as 0 to 2 volt. Here 1 volt. Here 0.5 volt. here 1.5 volt, here 1.75 volt, here 0.75 volt, here 1.25 volt, here 0.25, like that scale is there. Okay, already calibrated. Okay, now I'm taking my unknown value, this unknown, some x voltage, but what is this? I don't know. I'm keeping galvanometer here. If my x is 2 volt, if my x is 2 volt, the moment you are connecting here, it will show 0. First point. Suppose my x is not 2 volt, even if you're connecting this here, it will not show 0. Then what you have to understand? Okay, across this 2 is there, but this x is not the 2 volt. That's why we need to vary further. Yes, varying here, etc. Suppose I'm keeping at which one? At this point I'm keeping here. Suppose if it is showing 0, what does it mean? ఇది ఇక్కడ 0 చూపిస్తుంది అంటే it is showing 0 here means this voltage is equal to my input voltage. Are you clear?
ఓకే సార్.
Right, one more thing I'm saying.
మధ్యలో ఎక్కడైనా ఉండొచ్చు అన్నోన్ వాల్యూ అని చెప్తున్నారు అంతేనా?
అంతే కదా మన టాస్క్ అదే కదండి. 0 to 2 volts వరకు మీరు అంటే మీరు ఏమడుతున్నారంటే సింపుల్ చెప్తానండి. ఇలా డివైస్ ఉందండి, పాయింటర్ ఉంది కదా, సింపుల్ ఎగ్జాంపుల్ చెప్తున్నాను. పాయింటర్ ఉంది కదా, ఇప్పుడు మన అన్నోన్ వాల్యూ ఈ మధ్యలో ఎక్కడో దగ్గర ఉంటది కదా, అవునా? అవునా? అయితే అంటే నేను సింపుల్ ఎగ్జాంపుల్ చెప్తున్నాను. ఇది ఇలా చూపించింది అంటే ఏంట, ఇది 4 ఆల్రెడీ 4 ఉంది అంతే తప్పితే మనం అంటామా అన్నోన్ ఎప్పుడు 4 కి ఈక్వల్ కాదు. నా అన్నోన్ 4 ని చూపిస్తుంది, మీ అన్నోన్ వాల్యూ 5 ని చూపించవచ్చు. అంటే ఇక్కడ ఏమంటామంటే నేను ఇచ్చిన అన్నోన్ వాల్యూకి గ్యాలనోమీటర్ 4 దగ్గర ప్లేస్ చేసినప్పుడు, అంటే ఇక్కడ ఒక దగ్గర ప్లేస్ చేసినప్పుడు 0 చూపిస్తుంది. అంటే మన అన్నోన్ ఎప్పుడు కూడా ఈ రెండు మధ్యలోనే ఉండాలి కదా, అదే కదా. అంటే ఇది మీకు స్ట్రేట్ లైన్ చూపించాను. యాక్చువల్గా మీనింగ్ ఏంటి? స్కేల్ ఆఫ్ ద డివైస్ అన్నమాట. ఇండైరెక్ట్ గా ఇది స్కేల్ ఆఫ్ ద డివైస్. మన అన్నోన్ ఎప్పుడు కూడా ఈ మధ్యలోనే ఉంటుంది. కాకపోతే ఇక్కడ ఏంటి, ఫోర్స్ ప్రొడ్యూస్ అయ్యి పాయింటర్ మూవ్ అయ్యి డైరెక్ట్ గా ఆ వాల్యూని చూపిస్తుంది, బట్ ఇక్కడ ఆ వాల్యూ చూపించదు. అందుకని మనం ఇలా మూవ్ చేస్తా ఇక్కడ వచ్చింది అనుకోండి, ఓకే ఇక్కడ 0 అయింది కాబట్టి ఇక్కడ వోల్టేజ్ ఎంత ఉంది? 1. కాబట్టి మన అన్నోన్ ఎంత? 1. అందుకే చెప్పాను కంపారిజన్ బేస్డ్, నల్ ఇండికేటింగ్, నాట్ ద డిఫ్లెక్షన్ టైప్ అని చెప్పాను. ఇట్ ఈస్ నో క్లియర్?
బ్రేక్ ముందు డీసీ పొటెన్షియల్ మీటర్ చెప్పారు కదా సార్, బ్రేక్ ముందుకు.
అవును.
అప్పుడు మీరు గాల్వనోమీటర్ 0, ఇఫ్ గాల్వనోమీటర్ ఈజ్ ఈక్వల్స్ టు 0, అన్నోన్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్స్ టు నోన్ ఈఎంఎఫ్ అని అన్నారు కదా సార్. అందుకు
అదే ఇప్పుడు అర్థమైందా? మీరు మిస్ అయ్యేది ఏంటంటే ఈ స్ట్రక్చర్ లో చెప్పానమ్మా నేను. ఈ స్ట్రక్చర్ లో ఇప్పుడు ఈ గ్యాలనోమీటర్ 0 అయితే అన్నోన్ ఈక్వల్ టు నోన్ అవుతుంది. ఎందుకు? ఈ పొటెన్షియల్స్ మధ్యలో ఎంత వోల్టేజ్ ఉంది? నోన్ కదా, అందుకే ఇది సేమ్ అన్నాను. అయితే ఇప్పుడు నేను ఎక్స్ పెట్టానండి, ఎక్స్ పెట్టగానే 0 చూపించాలి గ్యారంటీ ఉందా? ఇది 10 అనుకోండమ్మా, నేను ఎక్స్ వోల్టేజ్ పెట్టాను, ఇది ఎక్స్ పెట్టగానే ఇది 0 చూపిస్తుంది, ఎక్స్ ఈక్వల్ 10 అని చెప్పేస్తాం డైరెక్ట్ గా? కుదరదు. ఎక్స్ గనక 10 అయితేనే ఇది 0 చూపిస్తుంది, అవునా? సపోజ్ ఎక్స్ ఇస్ 10 అనుకోండి, 0 చూపిస్తుంది. ఓకే, నేను వై పెట్టాను అంటే ఎక్స్ ఈక్వల్ టు 9 పెట్టాను అనుకోండి. సపోజ్ ఇది 9 ఇది 10, 0 చూపిస్తుందా? చూపిస్తుంది. అంటే మీనింగ్ ఏంటి? మనకి ఈ సర్క్యూట్ అనేది కంప్లీట్ సర్క్యూట్ కాదు. అందుకే ఏం చెప్పాను నేను, ఒకవేళ మన అన్నోన్ ఈఎంఎఫ్ కి గ్యాలనోమీటర్ 0 చూపించకపోతే మనకి వేరియబుల్ ఫెసిలిటీ అనేది కావాలి. ఆ వేరియబుల్ ఫెసిలిటీ గురించి మనం దీనికి వచ్చాము. 1 థింగ్. సెకండ్ థింగ్ సింపుల్ అమ్మా, ఇక్కడ 2 వోల్ట్, ఇక్కడ 10 వోల్ట్స్ ఉంది అనుకోండి, మీ వేలోనే వస్తున్నాను. 10 వోల్ట్స్ ఉంది, ఇక్కడ గ్యాలనోమీటర్ 0 చూపించింది, అన్నోన్ ఈఎంఎఫ్ ఎంత? 10 కదా. అదే చెప్తున్నాను, మళ్ళీ అదే చెప్తున్నాను చూడండి. దీంట్లో ఇక్కడ రైట్, ఇక్కడ నుంచి ఇక్కడికి నా నోన్ ఈఎంఎఫ్ ఎంత? 1 వోల్ట్. ఎలా తెలుసు మనకి? క్యాలిబ్రేషన్ ఆల్రెడీ చేసేసాము. ఇక్కడ గనక మన గ్యాలనోమీటర్ 0 చూపిస్తే అన్నోన్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్ టు నోన్ ఈఎంఎఫ్. ఎక్కడ చూపిస్తుంది? ఆ నోన్ ఈఎంఎఫ్. కానీ నోన్ అనే వర్డ్ ఎందుకు వాడట్లేదు అంటే, నోన్ ఈఎంఎఫ్ అంటే అందరూ బ్యాటరీ ఈఎంఎఫ్ అనుకుంటారు. అందుకని ఎక్కడైతే మనం నోన్ ఈఎంఎఫ్ ని క్యాలిబ్రేట్ చేసి పెట్టుకున్నామో ఆ వాల్యూ వచ్చేస్తుంది. అదే కదమ్మా, రెండు సేమే కదా. ఎందుకు కన్ఫ్యూజ్ అవుతున్నారు? ఇప్పటికైనా క్లియర్ అయిందా లేదా?
ఎస్ సార్. అంటే మీరు ఆ స్టేట్మెంట్ చెప్పినప్పుడు మళ్ళీ ఇక్కడ చూస్తే అంటే మీరు ఆ మధ్యలో ఎక్కడైనా రావచ్చు అనేసరికి ఈక్వల్ ఉండాలి కదా అని ఆ డౌట్ రేజ్ అయింది
బట్
సార్.
బట్ ఇప్పుడు క్లారిటీ వచ్చిందా?
ఓకే సార్. క్లారిటీ.
నెక్స్ట్
హలో సార్.
Yeah.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్.
సార్ ఇప్పుడు మనం అన్బ్యాలెన్స్డ్ లోడ్ లో స్టార్ 3 ఫేజ్ 4 వైర్ తీసుకుంటే అందులో మినిమం మాక్సిమం 3 వాట్ మీటర్ మాత్రమే యూజ్ చేస్తా ఉన్నారు కదా సార్.
మినిమం మాక్సిమం 2
మాక్సిమం 3 అంటే స్టార్ 3 ఫేజ్ 4 వైర్ సార్.
4 వేర్ 3 అవును.
అంటే ఇప్పుడు అక్కడ 2 వాట్ మీటర్ వాడకపోవడానికి రీజన్ అక్కడ న్యూట్రల్ లో కూడా కరెంట్ పాస్ అవుద్ది కాబట్టి న్యూట్రల్ వోల్టేజ్ కూడా ఉంటది కాబట్టి మనం 2 వాట్ మీటర్ మాత్రం యూజ్ చేస్తే మనకి అన్బ్యాలెన్స్డ్ పవర్ రాదనే సార్.
ఎస్ అంతే కదా. న్యూట్రల్ వైర్ ఉంది అంటే 2 వాట్ మీటర్ వాడద్దు అంటే న్యూట్రల్ వైర్ కూడా ఎక్కడ ఎఫెక్ట్ చూపిస్తుంది, సో వాడకూడదు. అది పాయింట్.
ఓకే సార్. సరే ఓకే సార్. సార్ అండర్ డౌట్ సార్. సార్ ఇప్పుడు ఆ సమ్ చేస్తున్నప్పుడు మనం ఒక కరెంట్ ట్రాన్స్ఫార్మర్ సమ్ చేసాం కదా సార్. అది రిలేలా ఉంటది. అక్కడ మీరు కరెంట్ అనేది 180 డిగ్రీస్ ఫేజ్ షిఫ్ట్ అవుద్ది అన్నారు కదా సార్. కానీ నార్మల్ గా ట్రాన్స్ఫార్మర్ లో అంటే 180 డిగ్రీస్ ఫేజ్ షిఫ్ట్ అయినా 216 అయినా 180 అంటే 36 అంతా వచ్చింది సార్ యాంగిల్. 180 ప్లస్ చేసినా 180 అది తీసినా మనకు ఆన్సర్ సేమే వస్తుంది అన్నారు సార్. కానీ ట్రాన్స్ఫార్మర్ లో వోల్టేజ్ కదా సార్ 180 డిగ్రీస్ ప్యూర్ లాగ్ ఉంటది కానీ కరెంట్ లాగ్ ఉండదు కదా సార్ 180 డిగ్రీస్ ఎగ్జాక్ట్ గా.
నేను ఆ మాట చెప్పలేదు. కొందరు ఏమడిగారంటే ట్రాన్స్ఫార్మర్ లో ఫేజ్ షిఫ్ట్ ఉంటది కదా సార్ అంటే ఫేజ్ షిఫ్ట్ అయినా కూడా అంటే అక్కడ యాంగిల్ 180 అని చెప్పలేదు. ఓవరాల్ ఏమనంటే మీరు 180 తీసుకున్నా కూడా ఎఫెక్ట్ అనేది సేమ్ ఉంటుంది అని చెప్పాను అంతే తప్పితే ఆ కరెంట్ అదే అని చెప్పలేదు. జనరల్ గా అంటే కొంచెం స్టూడెంట్స్ మెసేజ్ ఏం చేశారంటే సార్ ట్రాన్స్ఫార్మర్ లో 180 షిఫ్ట్ ఉంటది కదా అంటే 180 షిఫ్ట్ ఉన్నా కూడా మీరు అవుట్పుట్ తీసుకునేటప్పుడు వాల్యూ సేమ్ అది చెప్పాను తప్పితే మన 36.6 కరెక్ట్ 180 తీసుకోమనట్లేదు నేను. బట్ వాళ్ళ డౌట్ క్లారిఫై గురించి చెప్పాను అంతే.
ఓకే సార్. సార్ ఒక డౌట్ ఉంది సార్. అంటే ఏంటంటే ఇప్పుడు అన్ని అంటే పవర్ మెజర్మెంట్ అన్ని ఫేజర్ డయాగ్రామ్ తో చేసేస్తున్నాను సార్. కానీ టైం ఎక్కువ కన్జ్యూమ్ అయిపోతుంది సార్. అంటే ఏది ఫేజర్ డయాగ్రామ్ వాడుకుంటే బెటర్, ఏది ఇది సాల్వ్ చేస్తే ట్రిక్ సాల్వ్ చేస్తే
ఇవాళ చెప్పండి చూడండి. ఇవాళ ఫస్ట్ క్వశ్చన్ అది హోంవర్క్ క్వశ్చన్ చెప్పండి. అంటే మీరు అట్లా నేను చెప్పిన కాన్సెప్ట్ ని 1-2 సార్లు పక్కాగా చదివితే నేను ఏమైతే మాట్లాడానో నేను ఏమైతే రాశానో అవన్నీ మీరు పక్కా చదివితే మీకు ఈజీగా అర్థమైపోతుంది. ఓకే సార్ ఈ వేలో తీసుకున్నట్టు ఈ వేలో తీసుకుంటే అంటే మీరు ప్రాక్టీస్ చేస్తారు అంతే. ప్రాక్టీస్ అండి. ప్రాక్టీస్ అయిపోతే ఆటోమేటిక్ వచ్చేస్తుంది. అందుకే నేను చెప్తాను. కొందరు నాకు మెసేజ్ కూడా చేశారు సార్ ఈ మెథడ్ ఓకే కానీ మాకు ఫేజర్ డయాగ్రామ్ చెప్పారు. ఎందుకు అక్కడ సింపుల్ మెథడ్ ఉన్నప్పుడు ఫేజర్ డయాగ్రామ్ ఎందుకు? ఒక మెథడ్ చెప్పాను నేను, మీరే మెథడ్ లో వచ్చేస్తుంది కదా అది. అందుకనే ఫేజర్ డయాగ్రామ్ నార్మల్ మెథడ్ సింపుల్ అండి. క్వశ్చన్ లో యాంగిల్ ఇవ్వకపోతే డెఫినెట్ ఫేజర్ డయాగ్రామ్ డిపెండ్ అవ్వాల్సిందే. క్వశ్చన్ లో కనుక యాంగిల్ డైరెక్ట్ గా ఇచ్చినా ఇండైరెక్ట్ గా ఇచ్చినా ఫేజర్ డయాగ్రామ్ అవసరం లేదు. అది పాయింట్. ఇది ఒక్క పాయింట్ పట్టుకోండి, అన్ని సింపుల్.
ఓకే సార్. అంటే ఒక సమ్ సాల్వ్ చేశాను సార్. అక్కడ ఎల్సీ టైప్ కనెక్షన్ యూజ్ చేశారు సార్.
ఇక్కడ
అంటే ఒక సమ్ సార్ వర్క్ బుక్ లో ఉన్న సమ్.
కైండ్లీ సెండ్ చేయండి క్వశ్చన్. అట్లయితే నేను అంటే కొన్ని క్వశ్చన్ చూడలేదు అనుకోండి మీకు క్లారిటీగా ఇవ్వలేను.
అంటే నా డౌట్ ఏంటంటే సార్ అక్కడ వాడు లోడ్ పవర్ ఫ్యాక్టర్ అనేది ఒకటి తీసుకున్నాడు సార్. ట్రూ పవర్ మెజర్ చేయడానికి మనం VA cos phi అని రాస్తాం కదా సార్. సింగిల్ ఫేజ్ సార్ అది. మనం మెజర్డ్ పవర్ చేసినప్పుడు కరెంట్ వాట్ మీటర్ రీడింగ్ అదే అమ్మీటర్ రీడింగ్ ఇంటూ వోల్ట్ ప్రెషర్ కాయిల్ రీడింగ్ కరెంట్ కాయిల్ రీడింగ్ ఇంటూ మనం ఆ cos phi వేయకూడదా సార్?
మీరు ఎక్కడైతే అదే చెప్తున్నా నేను. ఫస్ట్ మీరు ఏం చేయాలంటే W రాసేసి V రాసి I రాసి cos phi రాసి కాస్ రాసి V ఎక్కడ ఉంది, పొటెన్షియల్ కాయిల్ ఎక్కడ ఉంది అది తీసుకోవాలి. కరెంట్ కాయిల్ ఎక్కడ ఉంది అది నేను మనకున్న క్వశ్చన్లు కూడా చూపించాను నేను. ఏంటి పొటెన్షియల్ కాయిల్ అనేది B కి N కి మధ్యలో ఉంది. కరెంట్ కాయిల్ అనేది ఇలా కనెక్ట్ చేసి ఉంది అవునా. ఇక్కడ వోల్టేజ్ ఇక్కడ ఎంత ఇచ్చాను 0.8 36.86 తీసుకున్నాను. బ్లైండ్ గా V తీసుకొని I తీసుకొని కాస్ ఆఫ్ 36.86 తీసుకోవచ్చా? లేదు. అందుకనే మీరు ఎక్కడ పొటెన్షియల్ కాయిల్ కనెక్ట్ చేస్తున్నారు, ఎక్కడ కరెంట్ కాయిల్ కనెక్ట్ చేస్తున్నారు అది మీరు పక్కాగా హోల్డ్ చేయాలి. దాన్ని బట్టి ఆన్సర్. ఇక్కడ ఏ లోడ్ ఇస్తే ఆ లోడ్ కాదు, ఆ లోడ్ కి పర్ఫెక్ట్ కనెక్ట్ చేశారు లేదు మనకు తెలియదు కదా. ఆ లోడ్ ఎప్పుడు తీసుకోవాలి మీరు? ఒకవేళ కరెంట్ కాయిల్ ఇలా కనెక్ట్ చేసి రైట్ పొటెన్షియల్ కాయిల్ గనక ఇలా కనెక్ట్ చేసి ఉంటే అదే లోడ్ తీసుకోండి. ఎందుకు? వోల్టేజ్ అక్కడే ఉంది, కరెంట్ అక్కడే ఉంది. అది పాయింట్.
సార్ ఇది నేను సింగిల్ ఫేజ్ లోడ్ గురించే చెప్తున్నాను సార్, 3 ఫేజ్ కాదు సార్, సింగిల్ ఫేజ్ లోడే సార్.
ఒకసారి సెండ్ చేయండి. సింగిల్ ఫేజ్ ఉంటే అదే లోడ్ తీసుకుంటాం మరి, బట్ ఏమైనా కనెక్షన్ లో మార్పు ఇచ్చాడేమో చూద్దాం.
ఓకే సార్, అది గేట్ 15 సీజన్ 2 సమ్ సార్ అది.
ఆ?
అంటే అది ఒక ప్రీవియస్ గేట్ సమ్ సార్ అది.
నో ప్రాబ్లం, నాకు సెండ్ చేయండి, నేను చెప్పేస్తాను. అది
ఓకే
అంత
సార్,
కాంప్లికేట్ ఉంటే నేను క్లాస్ లో సాల్వ్ చేస్తాను, ప్రాబ్లం లేదు.
అంటే కాంప్లికేటెడ్ ఏం కాదు సార్.
ఒకవేళ అనిపిస్తే నాకు అనిపిస్తే ఓకే పాయింట్ ఇక్కడ ఉంది అంటే నేను ఎక్స్ప్లెయిన్ చేస్తాను, లేదంటే మీకు పర్సనల్ గా నీకు రిప్లై ఇచ్చేస్తాను, ప్రాబ్లం లేదు.
ఓకే సార్, ఓకే సార్, థ్యాంక్ యూ.
రైట్.
Hello, good morning. Good evening, sir.
హూ ఇస్ దిస్? యా టెల్ మీ.
Sir, doubt ఏమంటే ఎనర్జీ కాన్స్టెంట్ ఈజ్ ఈక్వల్ టు,
కొంచెం గట్టిగా అమ్మా, కొంచెం గట్టిగా.
ఓకే సార్, అంటే K ఈక్వల్ టు నంబర్ ఆఫ్ రివల్యూషన్ బై ఎనర్జీ మెజర్. నో సార్,
అర్థం కాలే, నాకు వినబట్లేదు, కొంచెం గట్టిగా.
ఓకే సార్. సార్ కాన్స్టెంట్ K ఈక్వల్ టు నంబర్ ఆఫ్ రివల్యూషన్ బై కిలోవాట్. నో సార్, that will be energy
కిలోవాట్
measured.
అవర్. ఓకే,
That will be energy measured. Energy measured kilowatt hour. Okay. సార్ అంటే సమ్ లో ఏం చేశారంటే కిలోవాట్ మెజర్ అంటే అది మెజర్డ్ వాల్యూ లేక ట్రూ వాల్యూ సార్? అది
దాంట్లో ఎస్ మీరు అడిగారు క్వశ్చన్, అప్పుడు అడిగారు, ఆ క్వశ్చన్కి వెళ్తున్నాను. ఆ క్వశ్చన్ అప్పుడు మీరు అడిగారు, 1 సెకండ్, ఇదేనా? దీని ముందు ఇక్కడ అడిగారు, రైట్, ఇది ఇలాంటి క్వశ్చన్ అడిగారు మీరు, జాగ్రత్త చూడండి. మీటర్ కాన్స్టెంట్ అనేది ఎప్పుడు కూడా డిఫైన్ చేసి దాని ద్వారా వాల్యూ షో చేస్తుంది. కానీ ఇంత కన్జ్యూమ్ అయింది కదా అక్కడ, ఇంత కన్జ్యూమ్ అయిందంటే దీన్ని బట్టే రివల్యూషన్స్ వస్తాయి కదా ఇక్కడ. ఇంత కన్జ్యూమ్ అయిందంటే దీన్ని బట్టే రివల్యూషన్స్ వస్తాయి. కాబట్టి దీని ఏం చేస్తున్నాను, ఒకవేళ 1 కిలోవాట్ అవర్ ఎనర్జీ కనుక కన్జ్యూమ్ అయితే ఇది ఎన్ని రివల్యూషన్ చూపించాలి? 200 రివల్యూషన్ చూపించాలి. అయితే అకార్డింగ్ టు ది గివెన్ డేటా ఎంత ఎనర్జీ కన్జ్యూమ్ అయింది, ఇంత ఎనర్జీ కన్జ్యూమ్ అయింది. అందుకని రెండింటిని కంబైన్ చేసి ఇక్కడ ట్రూ వాల్యూనా మెజర్డ్ వాల్యూనా అవసరం లేదు. ఎప్పుడు తీసుకోవాలి అట్లాంటిది అంటే చూపిస్తాను. ఇంకో క్వశ్చన్ కూడా తీసుకున్నాను నేను. ఇక్కడ చూడండి, దీంట్లో హియర్ మీటర్ కాన్స్టెంట్ ఇచ్చారు, అది కాకుండా రివల్యూషన్స్ ఇచ్చారు, టైం కూడా ఇచ్చారు, లోడ్ కూడా ఇచ్చారు. అప్పుడు ఏంటి, 90 రివల్యూషన్స్ మాత్రమే అక్కడ కన్జ్యూమ్ అయింది. అంటే ఆ పర్టికులర్ లోడ్ కి 90 రివల్యూషన్స్ రొటేట్ అయింది. అప్పుడు మెజర్ ఎంత అంటే ఇది తీసుకుంటాం మనం. ఆ తర్వాత ఎంత కనెక్ట్ చేసాము అంటే ఇది కనెక్ట్ చేసాం, అది పాయింట్. అంటే మనం ఇచ్చిన డేటాని బట్టి తీసుకోవాల్సి వస్తుంది. ఈ క్వశ్చన్ లో ఏంటి, దీంట్లో డైరెక్ట్ గా ఏంటి ఇక్కడ, రైట్, ఇంత కరెస్పాండింగ్ మీటర్ కాన్స్టెంట్ ఇది మీటర్ కాన్స్టెంట్ ఉంది, ఇంత లోడ్ కనెక్ట్ చేసాము. ఓకేనా, ఇది మీటర్ కాన్స్టెంట్ ఉంది, ఇంత కరెస్పాండింగ్ రివల్యూషన్స్ ఉన్నాయి, రివల్యూషన్స్ ఇంత తిరిగితే షో అయ్యే వాల్యూ ఎంత అనడానికి ఈ రెండు కంబైన్ చేశాను. అయితే నెక్స్ట్ క్వశ్చన్ లో ఏం చేశానంటే ఇక్కడ ఇది కానీ రైట్, దీంట్లో ఏంటి, ఎన్ని రివల్యూషన్ తిరిగిందో చూపించలేదు అక్కడ మనకి, రివల్యూషన్ అడుగుతున్నాడు. అందుకని ఇంత లోడ్ కనెక్ట్ చేస్తే ఎన్ని రివల్యూషన్ రావాలి అంటే దీన్ని బేస్ చేసుకుని తీసుకోవాల్సింది, అలా తీసుకున్నాను. అయితే ట్రూ మెజర్డ్ అండ్ డిఫరెన్స్ లేదు ఇక్కడ.
ఓకే సార్. ఇఫ్ ఇన్ కేస్ డెల్టా వాల్యూ ఇస్తే, డెల్టా యాంగిల్ ఇస్తే అప్పుడు మేము మెజర్ వాల్యూ పోవాలి కదా సార్? క్వశ్చన్
డెల్టా వాల్యూ ఇస్తే
మెజర్ వాల్యూ కనుక్కోవాలా?
ఏ డెల్టా అనేది డెల్టానా?
సార్ యాంగిల్ బిట్వీన్
డెల్టా ఇచ్చారు అనుకోండి, సైన్
మేము
డెల్టా -5 v ఇంటూ i ఉంది కదా,
అప్పుడు మేము ఇదే ప్రిఫర్ చేయాలి కదా సార్ మెజర్డ్ వాల్యూ అంటే?
ప్రిఫర్ చేయాల్సిన అవసరం ఏముంది, వాళ్ళు ఏదైతే ఫైండ్ అవుట్ చేయాలండి. డెల్టా ఇచ్చి ఎర్రర్ ఫైండ్ అవుట్ చేయమంటే ఇది ఎందుకు అంటే ఇది పవర్ లో మళ్ళీ ఒక పాయింట్ మిస్ అవుతున్నారు మీరు. ఇది ప్రిఫర్ చేయాలి, అది ప్రిఫర్ చేయాలి మ్యాటర్ కాదండి ఇక్కడ. ఒక్క నిమిషం, దీంట్లో ఏం అడిగారు వాళ్ళు, ఎర్రర్ ఇన్ ద వాట్స్ అడిగారు. వాట్స్ కాబట్టి పవర్ ఫార్ములా కాబట్టి ఇక్కడ ఎర్రర్ ఇన్ ద పవర్ తీసుకోవాలి. లేదు అంటారా, ఎర్రర్ పర్సంటేజ్ లో అడిగారు అనుకోండి, ఎనర్జీ రిలేటెడ్ ఎర్రర్స్ చాలా చేశాం కదా, ఎస్ ఈ ఎర్రర్స్ ఇలా ఫైండ్ అవుట్ చేస్తూ తీసుకోవాలి. మీకు ఆప్షన్ లో ఏమడిగారు, వాల్యూ ఫార్మ్ ఆఫ్ పవర్ లో అడిగారా, ఎర్రర్ పర్సంటేజ్ లో అడిగారు, దాన్ని బట్టి అంతే. డెల్టా ఇస్తే ఇది ప్రిఫర్, డెల్టా లేకపోతే అది ప్రిఫర్ కాదు. డెల్టా ఎందుకు ఇచ్చారంటే పవర్ అడిగారు కాబట్టి అక్కడ. మిగతా క్వశ్చన్ లో ఎనర్జీ డైరెక్ట్ ఇచ్చేసారు, సో ఎనర్జీ ఎర్రర్ ఫైండ్ అవుట్ చేస్తారు.
సార్ ఇంకో జనరల్ డౌట్ ఏంటంటే మేము ఎనర్జీ మీటర్ కనెక్ట్ చేస్తాం కదా సప్లై నుంచి డైరెక్ట్ ఇంటికి.
కొంచెం ఏమనుకోవద్దు, కొంచెం గట్టిగా మాట్లాడండి ప్లీజ్.
ఓకే సార్, నేను గట్టిగా మాట్లాడుతున్నా సార్.
ఇప్పుడు ఓకే, ఇది ఓకే.
ఓకే సార్. సార్ మేము ఎనర్జీ మీటర్ డైరెక్ట్ సప్లై నుంచి కనెక్ట్ చేసాం కదా సార్, అంటే మెయిన్ పవర్ సప్లై నుంచి. మళ్ళీ సప్లై అంటే అక్కడ మేము ఏదైనా ఓవర్ వోల్టేజ్ వస్తే మాకు ఎనర్జీ మీటర్ డ్యామేజ్ కాదా సార్?
అంటే జనరల్ గా
అంటే
ప్రాబ్లం
అక్కడ
ఉంది.
ఎంసీబీ కనెక్ట్ చేయం కదా సార్, అడిగితే మీరు చెప్పారు కదా సార్ ఎంసీబీ కనెక్ట్ చేయమన్నారు. అంటే అక్కడ మేము ఎంసీబీ కనెక్ట్ చేయం. ఎంసీబీ అంటే ఇంట్లో కనెక్ట్ చేసాం కదా సార్, అంటే ప్రొటెక్షన్ ఫర్ ద హోమ్ అప్లికెంట్ కోసం.
అవును.
కానీ అప్పుడు మేము ఎట్లా కంపల్సేట్ చేయాలి సార్ అది ఎర్రర్ కి, ఓవర్ వోల్టేజ్ కి?
ఓవర్ వోల్టేజ్ జనరల్ గా ఇది క్వశ్చన్ మంచిదే, బట్ జనరల్ గా ఛాన్స్ అయితే ఉంది, ఓవర్ వోల్టేజ్ ఛాన్స్ అయితే ఉంది. యాక్చువల్గా చెప్పాలంటే ఎనర్జీ మీటర్ లోనే చాలా రకాల ప్రికాషన్స్ ఉంటాయి. యాక్చువల్గా మనం చెప్పింది ఓన్లీ ఆపరేషన్ మెజర్మెంట్ గురించే. దాంట్లో ఓవర్ వోల్టేజ్ ప్రొటెక్షన్, ఓవర్ లోడ్, ఓవర్ కరెంట్ ప్రొటెక్షన్, అన్ని ప్రొటెక్షన్స్ ఉంటాయి అన్నమాట. దాన్ని బట్టి మనకి ఎనర్జీ మీటర్ సేవ్ అయిపోతుంది జనరల్ గా. అంటే మీటర్ లో మనం తీసుకుంది ఏంటి, ఓన్లీ మెజర్మెంట్ ఆఫ్ ఎనర్జీ మట్టుకి మన టాపిక్. యాక్చువల్ గా ఇన్ ద ఎనర్జీ మీటర్ ప్రొటెక్షన్ పాయింట్ ఆఫ్ వ్యూ, ఓవర్ లోడ్ ప్రొటెక్షన్, ఓవర్ కరెంట్, యాక్చువల్లీ ఇలా ఉంది కదండి, ఇలా కరెంట్ కాయిల్ ఉంది కదా, సారీ ఇలా సిరీస్ మ్యాగ్నెట్ ఉంది కదా. యాక్చువల్ గా ఈ రెండింటి మధ్యలో ఒక కోర్ ప్లేస్ చేస్తాము. అవన్నీ లేవు అనమాట, యాక్చువల్ ప్రొటెక్షన్ స్కీమ్స్ లేవు. దీని ద్వారా ఓవర్ కరెంట్ ప్రొటెక్షన్, ఆ తర్వాత పొటెన్షియల్ కాయిల్ సైడ్, షంట్ మ్యాగ్నెట్ సైడ్ కూడా ఒక రకమైన ప్రొటెక్షన్ ఉంటుంది. అవన్నిటి వల్ల మనకి ఓవర్ వోల్టేజ్ వచ్చినా, అండర్ వోల్టేజ్ వచ్చినా, ఓవర్ కరెంట్ వచ్చినా ప్రొటెక్షన్ జరుగుతుంది. సో ప్రాబ్లం ఏం లేదు. దట్టు నోటీస్ అంతా ప్రోగ్రామబుల్ కదండి, అంతా ఓవర్ వోల్టేజ్ అంటే ప్రోగ్రామబుల్ అయి ఉంటుంది. బట్ మన సర్క్యూట్ లో ఓవర్ వోల్టేజ్ అండ్ ఓవర్ కరెంట్ ప్రొటెక్షన్ స్కీమ్స్ ఉంటాయి, బట్ మన మెజర్మెంట్ టాపిక్ లో తీసుకోమంతే.
సార్ ఇంకో డౌట్ ఏమంటే, ఎస్టేట్ ఒక ప్రాబ్లం చేశాను నేను డైనోమీటర్ పైన. అక్కడ ఏం ఫైండ్ చేయమన్నారంటే ఎర్రర్ ఫైండ్ చేయమన్నారు సార్. సార్ దాంట్లో ఏమన్నారంటే 0 పవర్ ఫ్యాక్టర్ అని ఇచ్చారు సార్. యాక్చువల్ గా ఎర్రర్ ఈజ్ ఈక్వల్ టు tan phi into tan beta నో సార్. సార్
చెప్పండి.
అప్పుడు మాకు 0 పవర్ ఫ్యాక్టర్ అంటే అక్కడ మాకు phi ఈక్వల్ టు 90 degrees నో, 90 degrees నో సార్.
పర్ఫెక్ట్ 0 అంటే 90 degrees.
అప్పుడు మాకు ఎర్రర్ అంటే ఇన్ఫినిటీ వస్తాయి కదా సార్.
మాక్సిమం ఎర్రర్ అంటాం దాన్ని, మాక్సిమం అనాలి, ఇన్ఫినిటీ అనకూడదు, మాక్సిమం అనాలి.
ఆన్సర్ లో అట్లా ఏం లేదు సార్, డైరెక్ట్ ఏమి ఇచ్చారంటే VI sin phi into tan beta ఇచ్చారు సార్.
ఓకే,
అప్పుడు ఆన్సర్ ఇన్ఫినిటీ వస్తలేదు సార్, 0.15 అట్లా వస్తుంది సార్ ఆన్సర్.
ఒక్కసారి నాకు పంపండి చూస్తాను. అంటే కొంతమందికి ఎందుకు చెప్తానంటే, మీరు సరిగా చెప్పలేకపోయినా, నాకు సరిగా అర్థం కాకపోయినా రాంగ్ నోటేషన్ ఇవ్వాల్సి వస్తుంది. అందుకని సెండ్ దట్.
ఓకే సార్, ఐ విల్ సెండ్ యూ.
రైట్.
Good evening, sir.
Yeah, tell me.
Yes, sir. I don't have the doubt. I just wanted to confirm that I've understood it correctly, sir. In DC Crompton's potentiometer, while doing the calibration, first we are fixing the in the sliding wire. We are fixing the value at 10.18 centimeter according to your standard, sir.
101.8. Yes,
sir. And then fixing the value of resistance box to a value, and then varying the rheostat, we are maintaining 10 milliampere.
Very good. Perfectly correct. Perfectly. That is what the calibration. But no need to stress that we are fixing the rheostat box, we are fixing the slide wire. No need to say. Simply, we are keeping the slide wire across 101.8 ohms in the entire circuit resistance, and we are weighing the rheostat to maintain the. That's very good. Very happy. Thank you.
Okay, sir. Thank you.
Right.
Hello, sir.
Yeah.
Sir, actually, I have a doubt in day before yesterday's class. I did not listen, and today morning I listened, sir. That's why I'm asking today, sir.
Yeah, tell me.
Sir, in Blondel's theorem, you said about that minimum and maximum in 3-phase 4 wires, sir.
Yeah.
But you told we should not connect 2 wattmeters, two wattmeters in 3-phase 4 wire connection, no, sir, because he will give neutral. Then you gave maximum 3 now, sir, in that.
Yeah, so what? Maximum 3 means?
Maximum 3 means we can also connect to 2 now, sir.
No, that is not the meaning. Maximum number 3, minimum number also 3. What does it mean?
Okay, only 2 numbers, sir, 1 and 3. Okay, sir.
That's what.
Sir, here today's first problem.
Yeah.
Sir, today's.
Tell me. Hello.
You take.
Voice is
Hello,
not
sir.
clear. Yeah, tell me.
Hello. Hello, sir.
Yeah. Hello.
Sir, they gave.
Yeah,
Hello, sir.
tell me.
Hello.
Tell me. I'm able to hear. Can you tell me?
Sir, can you please explain once?
Which one?
Sir, can you please explain once that problem, sir?
Total
Today's
problem
first problem,
expression is
sir.
not possible. If any doubt is there at any point, you tell me. Otherwise, watch the recorded video. Total problem expression is not possible again.
Sir, they gave a sequence, but they told that we should consider a negative sequence.
Who told that?
Reverse sequence.
Who told that?
Sir, we took na, sir, in that problem, first problem.
See, that's what I told you. I repeated this statement also. At that time, you typed one message like, sir, yes, due to some problem, etc. I attended the classes. I will ask you at the end of the time. You were typing that message actually at that time. That's why you missed it. See, RYB sequence. Okay, RYB sequence he has given. Okay, in this RYB, reversely he has taken, means in the shortcut point of view, whatever the thing we have taken in the explanation point of view, have taken, what is that? RYB anti-clock, but he has taken clockwise. That's why in the place of minus I kept plus, in the case of plus I kept minus. That is what the point I gave you. But immediately I told the procedure. This is only circuit diagram. It is not the sequence model. From this we cannot get the sequence. From phasor diagram we get the sequence. So that's why in the phasor diagram RYB sequence only we have to take. Always anti-clockwise sequence only we have to take. That is what the standard procedure already told you in the term of explanation also. But your doubt is genuine. What is that? So circuit is like this, so there it is reverse. No, from the circuit we should not decide the phase sequence. From the phasor diagram only we have to. But why I have taken RYB reverse means from my explanation point of view, this is reverse concept, so that I have given the shortcut directly.
Okay, sir. If we change the polarities, then we can take reverse also, no, sir?
Yeah.
Okay, sir.
Sir, 25F, sir.
Yeah. 25F, nothing is there.
Sir, basic slide wire potentiometer.
Yeah.
Sir, ఇక్కడ మనం మెజర్మెంట్ చేసినప్పుడు గాల్వనోమీటర్ నల్ పొజిషన్ ఇక్కడ స్లైడ్ వేర్ మీద వేరీ చేస్తూ అన్నోన్ ఈఎంఎఫ్ తెలుసుకుంటున్నాం కదా సార్.
అవును.
అలాగే మనం స్టాండర్డ్ సెల్ లో కూడా గాల్వనోమీటర్ 0 అలాగా అప్టెండ్ చేస్తామంటే రియోస్టాట్ వేరీ చేస్తాం కదా సార్.
అవును.
అదే రియోస్టాట్ అన్నోన్ ఈఎంఎఫ్ మెజర్మెంట్ చేసినప్పుడు వేరీ చేసి గాల్వనోమీటర్ నల్ పొజిషన్ తెచ్చుకోవచ్చా సార్?
అప్పుడు చేస్తే మనం ఎలా అంటే ఇప్పుడు 0 పొజిషన్ వచ్చింది, ఇక్కడ ఎక్కడో దగ్గర వచ్చింది అనుకోండి సపోజ్. అప్పుడు ఏమవుతుంది? కరెంట్ వేరీ అవుతుంది కదా. కరెంట్ వేరీ ఎలా ఫైండ్ అవుట్ చేస్తారు? అన్నోన్. దీంట్లో కరెంట్ ఎంత ఉంటుంది? ఆ రెసిస్టెన్స్ ఇంటూ చేయాలి కదా. ఇది వేరీ అవుతుంటే కరెంట్, అందుకని మన పాయింట్ ఏంటి? కరెంట్ అనేది కాన్స్టెంట్ ఉండాల్సిందే. అందుకని క్యాలిబ్రేషన్ అప్పుడు ఇది వేరీ చేయాలి, మెజర్మెంట్ అప్పుడు ఇది ఇక్కడ ఇలా కనెక్ట్ చేస్తూ వేరీ చేయాలి.
అంటే అక్కడ డ్రాప్ వేరీ అయిపోతుంది కాబట్టి మనం కరెంట్ అనేది కాన్స్టెంట్ గా వేరీ అదే అప్టెండ్ చేయాలి సార్ కరెంట్ అనేది.
అది వెరీ గుడ్
సార్. మళ్ళీ నా వాట్ మీటర్ లో అంటే మనం న్యూట్రల్ అనేది మనం ఒకసారి అంటే మన లోడ్ డెల్టా ఉండి సోర్స్ అనేది స్టార్ ఉన్నప్పుడు మనకి న్యూట్రల్ ఉంటది కదా సార్. మరి అప్పుడు వాట్ మీటర్ అంటే అక్కడ మనకి ఇక్కడ డెల్టాలో న్యూట్రల్ లేదు కదా, అక్కడ స్టార్ సోర్స్ ది తీసుకోవచ్చా సార్ న్యూట్రల్ అలాగా?
మీరు ఎక్కడ మెజర్ చేస్తున్నారు? సోర్స్ పవర్ మెజర్ చేస్తున్నారు, లోడ్ పవర్ మెజర్ చేస్తున్నారు. అది పాయింట్ అక్కడ.
లోడ్ గా మెజర్ చేస్తుంది సార్. కాకపోతే సోర్స్ అదే లోడ్ ఎక్కువ, ఎప్పుడైనా కరెంట్ తీసుకున్న సోర్స్ నుంచి కదా కరెంట్ అనేది ఎక్కువ అవుతుంది కదా, అప్పుడు ఎక్కడ కనెక్ట్ చేసినా పెరుగుతుంది కదా సార్.
ప్రాబ్లం లేదు. ఇప్పుడు మీకు జాగ్రత్త చూడండి, మీరు అడిగేది సోర్స్ టు లోడ్ కనెక్షన్ కదా. సోర్స్ ఇలా ఉంది, ఓకే, ఇక్కడ లోడ్ ఇలా ఉంది, ఇదే కదా.
అవును సార్.
అంటే ఇప్పుడు న్యూట్రల్ వైర్ ఉందా లేదా మీ దాంట్లో?
ఉన్నది సార్, ఇక్కడ స్టార్ లో
ఉంది. ఓకే, అయితే ఇది ఎటువంటి అప్లికేషన్ లో వస్తుంది? అసలు ఫస్ట్ అప్లికేషన్ ఉందా ప్రాక్టికల్ గా, అది చెప్పాలి మనం.
అప్లికేషన్ పాసిబుల్ గా ఉండదు అనుకుంటున్నాను సార్.
అది వెరీ గుడ్. అందుకని ఏమనంటే ఇలా డెల్టా ఎప్పుడైతే ఉంటుందో మనం అక్కడ 3 phase 3 wire సిస్టమ్ ని తీసుకున్నాం. అందుకనే చెప్పాను, ట్రాన్స్మిషన్ లైన్ లో స్టార్ అయినా డెల్టా అయినా సరే ఒక పవర్ స్టేషన్ నుంచి ఒక 100 kilometers రన్ అవుతుంది అంటే డెల్టాలో తీసుకుంటాము. లేదంటే డెల్టాని జనరల్ గా, లేదంటే స్టార్ 3 wire తీసుకుంటాము, 4th wire తీసుకోము. అలా తీసుకొచ్చి ఫైనల్ గా ఈ న్యూట్రల్ వైర్ ఎప్పుడు ప్లేస్ చేస్తామంటే ఎక్కడైతే ఫేస్ న్యూట్రల్ మీన్స్ సింగిల్ ఫేస్ లోడ్స్ ఉన్నాయో అక్కడ మాత్రమే. అందుకే ఏమంటానంటే నేను, మనం బ్లైండ్ గా మనం ఆలోచించినప్పుడు ఇది ఉంటే ఏమవుతుంది, అది ఉంటే ఏమవుతుంది అని డౌట్స్ వస్తాయి మీకు జనరల్ గా. అందుకని ఇది ఉంటే ఏమవుతుంది, గుడ్ క్వశ్చన్. కానీ ఇది ఉంటుందా ఫస్ట్ ఆఫ్ ఆల్, అది అంటే సింపుల్ ఆన్సర్ వచ్చేసి ఇది ఉండదు అసలు జనరల్ గా. అది పాయింట్
సార్. మళ్ళీ నా ఇంకా బేసిక్ సార్, అంటే నేను ఇప్పుడు కాలేజ్ 3rd year చదువుతాను సార్. అంటే ఒక్కొక్క ఇది ఒక్కొక్క ఎన్ఎస్ఆర్ఐటి సార్, ఏపీ సార్, విశాఖపట్నం.
ఓకే ఓకే.
అంటే ఒక్కొక్క కాలేజ్ ఒక్కొక్క గేట్ అలా మేనేజ్ చేయాలి, కొంచెం ఏమైనా టిప్స్ చెప్తారా?
చెప్తానమ్మా. జనరల్ గా నేను ఈ షెడ్యూల్ కంప్లీట్ చేసి మీకు టిప్స్ ఇస్తాను. జనరల్ గా చెప్తాను, ఒక రోజు అందరికి కలిపి చెప్తాను. నో వరీస్.
ఓకే సార్, థ్యాంక్ యూ సార్.
Hello sir, good evening.
Yeah, good evening. Tell me.
Sir, I have a doubt regarding energy emitter shunt and series magnets. Why they are shaped like that, sir? Can we use directly shape of the magnet, sir?
Actually, I see the shape of the magnet means this is E shape. Okay, E shape structure. Actually, E shape means only for idea purpose I am extending like this, but actually it will be like this. Normally E shape structure. Okay, now one student asked out, sir, if any over voltage etc., for all those protections we are going to keep one more thing like this. We are going to keep one more core type structure for other protection, but in our measurement those protections are not required. If you are keeping like this, over voltage protection, over current protection etc., will be coming. This is one way. And sometimes we are going to keep some core here also. Different types of protections, possibility purpose. Generally this is E shape and this is C shape, but protection is not in the measurement. That's why gate or ESC or any competitive protection is there, not there, no problem. Only for having those facilities here we need to keep, so it should be having the corresponding path like this. Here also, here we can keep, or here like that. So many protection scheme for that purpose we are taking. Other than nothing, no other reason.
It has no specific reason, only this.
Yeah, protection, no specific.
Okay.
Generally, see, one second, if you see the textbook directly, the potential shunt magnet is in the E shape, full stop, that's it.
Yes,
shunt series magnet is in the C
yes.
shape, that's it. That's what the point.
Sir, one more, sir.
Yeah.
Sir, remove all those except those 2 magnets, sir. Back.
Yeah.
Sir, enough for.
Yeah.
Sir, now draw the flux, sir. How I know the windings, how they will be arranged.
This is a 2-dimensional, 3-dimensional flux we cannot do. That's why be clear. Wherever we can draw practically, diagrammatically, flux lines we can draw. But in the 3-dimensional picture, we cannot draw this because it is induction motor principle. Because, very good question. This is coil and here it is coming here. Like this is there, right? We cannot draw the complete. Simply if I draw, these flux lines are coming, these flux lines are coming like this only. There's only practical visualization. So it is not possible. Not for me. Generally not there. No need to worry.
Sir, I am thinking that from the above magnet we'll get 3 paths through the air into the disk, and from below getting 2 paths of flux, because it's a electromagnet, sir. The flux will flow into the 3 limbs and it will come to the disk through the air gap like that.
Not exactly. Not exactly, but even though it is looking like correct, but not exactly. So that way, don't concentrate on that. Openly speaking, don't concentrate.
Okay, sir. Okay, sir.
And Mubin, I
Sir.
wanted to ask you. So
Yes,
you are from which college?
I'm Usmania, sir.
University.
Yes, sir.
Okay, you Polytechnic from?
Masab Tank, sir.
Okay, right. You are which year?
Now I'm third, sir.
Okay, right, no problem. Because you told on one day, sir, in my Polytechnic, like that you told. That's why I wanted to ask, because I'm also from Polytechnic. That's why.
Yes, sir. That's why it's very comfortable to hear your classes.
And that too, as you're asking the questions, no, that's why I'm able to understand. Okay, where you are studying. Okay, right. Thank you.
Sir, one more, sir. In the phantom loading, we know V and we know I. We rated across potential and I rated through the current coil.
Current coil, yeah.
But what is the power factor? I mean, we have to calculate VI cos phi.
No, you know, you're missing. What you are keeping? Rheostat, no, resistance. So power factor 1 only. That's why I told you, no. Here 250, 4 ampere, power factor is 1000 for 1 hour. As I kept a resistor, I need not to mention the resistor means. That's why calibration is generally for resistor loads only.
Yeah, that's why. Yeah.
Right.
Sir, even now, if practically we have done, sir, now there we have lagging loads, then due to power factor change, the measured power will be less than the actual, na, sir.
Definitely. There will be there, definitely.
That will be error, na, sir, or anything else?
Yes. But experimentally, if I show the error, no, so how do we minimize this? That's why for load 1 we have taken, this is experiment. So that is enough actually, subject point of view. Experimentally, we can play. We can keep 0.8 lagging, 0.6, we can analyze it. As the load is changing, more lagging, more error, less lagging, less. In that way we can.
Sir, do you have any theoretical, like, important points altogether? Like,
but actually, for every topic I'm giving, but still people are asking, sir, few more points required. Why?
Because all those points were initially here in our classes, schools. Only 20-30% were very interesting. I mean, new points here. I'm thinking there are many other things also. That's why I asked.
No, actually, whatever the thing is to be given in the class notes, I'm writing everything I'm giving.
Yes, sir.
Not required more than that.
Not required. With respect to GATE and all exams.
See, for GATE and DSC, that too, more than required only I'm giving. So no need to worry.
Sir,
so wherever when I'm
please.
speaking, orally I'm speaking, for example, that I cannot write. No need to write.
Yes.
But each and every point I'm writing, whatever you require. That's when the energy meter, I gave some typed notes yesterday.
Yes.
Because if I write, something may be missing sometimes. That's why I give clearly point. That's why wherever the notes is to be given, I will write. Otherwise, I will give that note kindly. No problem.
Yeah, thank you. Sir, one more, sir. Sir, in our college, placements are going on.
Okay.
But if I get, sir, one thing I want to ask, what are the core companies usually come, because you have interacted with many students now, sir.
Yeah.
What are the usual core companies?
Generally, I would like to say openly, in our state level colleges, 90% of the colleges, there are no core companies, openly speaking. Right? Okay. Only few colleges, that too in the OU or JNTU or any old college like this, it is possible, but that is also very, 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 very less, but to normal companies only. Normal to normal companies. I can say openly, 99%, many colleges, no campus placement related core companies. Mostly in our state level, we will be having only which in software companies only. That's why no need to focus, I say generally.
Sir, is it better to take job after BTech or complete that MTech, sir? Just a personal opinion.
No, I see. Two things are there. After the BTech, if job is there, security will be there. Because of this COVID period and all, everyone is thinking like security is important like that. Okay, security. Yes. So few people are saying that even though government job is not there to me, even though it is private, I will survive. They are going to MTech. But even after MTech, you can write the job. But people are saying that once in a BTech, if I get in the job, why to lose? That's why people, because two different mentalities. I have seen many people, even though they got the government job, PSU, etc., they left it and they went for MTech in the IITs and all. But a few people, they left the MTech and they came and joined in the PSU. That depends on the person mentality as well as family background also.
Sir, what should be the range of rank to get at least a good government job, sir?
At least good government job means below 100 means all companies you will be eligible.
Yes.
200 means 1 or 2 companies will be missing. 300 means like that. 500 below, for example, 2-3 companies will be chances there. So that's why
500.
always target for at least 100 below.
Okay.
That's the main target actually. Simple here in your BTech also same thing, no? If you have 85 plus percentage, 10 companies
Yes.
will give the eligibility. 80, only few companies. 75, further 4. Like that, same thing happened.
So
You always
500.
target for the best. Target for the best. Actually, I'm suggesting you people target single digit. If you target a single digit, worst case you'll get double digit. Happy 199. That's
Yes,
what.
sir.
Okay.
Yes, sir.
Right.
Thank you, sir.
Right.
Hello.
Yeah.
Hello. Yes, sir. Actually, I had a doubt in the volume 2, sir. In the that AS has provided those books.
Yeah.
No, sir.
Can you tell me the question?
Sir, in measurement of voltage and current,
Yeah.
in it, it is given that a voltmeter having sensitivity 1 kilo ohm per volt is connected across an unknown resistance in series with milliammeter, reading 80 volt on 150 volt scale. And when the milliammeter reads 10 milliampere.
Okay. What is your doubt in that?
Sir, in that actually, first they have given to calculate the apparent resistance, which I have calculated, sir. In second question, they have asked to calculate actual resistance, sir. Actual resistance of the unknown resistance, sir.
Okay.
Sir, in that they have taken, sir, I have solved it, but I have tried it, sir. In that
okay, no
they
problem. Do one thing. Send that question. I can give more clarity, which is correct. Where you are mistaking or anything.
Yes, sir. I have sent you both the books answer also, and what I have tried, that also I have sent, sir.
When?
Sir,
no or?
Sir, yesterday at night, sir. Actually, I think you thought that I am asking about homework questions, sir. So that's why I think you did not see, sir.
Say hi just now. It will come into top now. I will do this. No problem.
Yes, sir. 1 minute, sir. Huh?
Yeah. You send that. I can clarify. No problem.
Yes, sir. I will send you hi just now, sir.
Right. Okay.
Hello, sir.
Anil Kumar?
Sir, good evening, sir. Hello. Hello.
Yeah.
Sir, I have a doubt, small doubt in potential.
There is a question in this. You send the solution only. Come on. Okay. First question. Voltmeter having sensitive 1 kilo ohm per volt connected across unknown resistance series with milliampere. Okay. Actual resistance of unknown resistance. Why that minus is there, right? Okay,
yes, sir.
do one thing. Yeah,
yes,
do
sir.
one thing. Actually, it is based on some assumption taken. Okay, I will solve this in the normal way. I'll send you, no problem. No need to take minus in the normal way. I'll send you and I'll do it and I'll send you.
Okay, sir. Thank you, sir.
Right. Okay then. Good night, everyone. Thank you. Tomorrow, Sunday, 2 o'clock.